conference SPIN 2025. I also wish to extend a warm welcome to all the attending delegates and paper presenters. It is a great privilege to have Dr. Hancock No with us today. I would like Dr. Anil Kumar Shukla to present a sapling to Dr. Hancock No.
Welcome, sir. Welcome, Professor.
Yes, hello. Can you hear me? Hi, can you hear me?
Yes, yes, you are audible, sir.
Okay, all right, thank you.
Dr. Hancock No is currently a reader associate professor at Queen's University Belfast and a UKRI Future Leaders Fellow. His main research interests include massive large-scale MIMO systems, cell-free massive MIMO, physical layer security, and cooperative communications. He has co-authored many research papers in wireless communications and co-authored the Cambridge University Press textbook, Fundamentals of Massive MIMO 2016. He has received 3 prestigious prizes, the IEEE Comstock Stephen O. Rice Prize in 2015, the IEEE Comstock Leonard G. Abraham Prize in 2017, and the Best PhD Award 2018 by the European Association for Signal Processing, EUROSIP. Welcome once again, sir. We are honored to have you grace at SPIN 2025. Now I request Dr. Hancock No to present on his topic, physical layer security in cell-free massive MIMO.
Yeah, thank you very much for your introductions. Let me share my screen. So can you see my slide?
Yes, yes, it is visible, sir.
Okay, thank you very much. So hello everyone. Firstly, I would like to thank the organizers, especially Professor Dubai, for kind invitations. It's my great pleasure to give a talk here at SPIN 2025 years. So the topic I'm going to present today is physical layer security in cell-free massive MIMO. So this is the outlines of my presentation. Give me a second, please. First, I will give very brief place about cell-free massive MIMO. Why cell-free massive MIMO? What is cell-free massive MIMO? And then I will focus mainly on the physical layer aspects in cell-free massive MIMO. So we will go through two different scenarios. The first one is cell-free massive MIMO is under active eavesdrop burst, and a very different scenario is that cell-free massive MIMO is actually is an eavesdropper which we apply for surveillance system, and then they will provide conclusion and filter rejection here. Okay. So we all know that over the past nearly 50 years, so our mobile network is based on cellular topology. So where this is a very large areas is divided into small areas, and this area will be served by one base station. So this one we call it a cell. Okay, so this is cell and cell and cell. And the users in each cell will be served by the base station. For example, this user will be served by each base station, this user will be served by each base station, and so on. Okay. So this is the reason for why we call this is cellular network. So the cellular network is very simple, work really well up to now. However, it still its own way has an inherent limitation called cell boundary effect. For example, look at this user. So this user is inside this cell, right? So it will be served by this base station. So this base station want to transmit signal to this user, right? But because in the boundary of this cell, it's very far from this base station, therefore the signal received at this users is not very strong. At the same time, the interference from other base station from other cells to this users is strong, and also from other user in other cells as well to this user is strong. So therefore, the performance of this user is not very good. So the poor performance of this user will affect the whole system performance, especially if we look at the connectivity, right? So this problem is not an issue in the past, but in the future you can see that the number of mobile device increasing. We have like 100,000 or even million of user connected at the same time, and also we have more requirement on the speed and so on, connectivity, because of the application. We have more advanced application now. Therefore, the boundary effect becomes serious now, and that's the reason for why we can see that at some point we lost the connection. So the connectivity of the network is not very good, right? So how to overcome these problems? We know that whatever the technique we use, if we still based on the cellular structure here, so we still have cell boundary here, right? And then we still have the boundary effect, the usual in the boundaries of the cell. So whatever the advanced technique we use, you cannot overcome this. The only way to overcome the boundary effect is removing the cell. So if we don't have cell, then we don't have boundary, right? So that is the motivation of proposing the cell-free massive memory system, where we don't have any cell now. We have many access points, so it is like small base station. Coherently serve all users in the network. So this idea is first proposed in these papers in 2017, and it has been adapted a lot of research interesting then actually. So just in more detail, so cell-free massive memory actually is the system including many access points, so distributed in the large areas, coherently serve all users in the network. There is no cell and cell boundary here, so that's the reason we call it cell-free here. So the assumption is that the the total number of service antennas should be much greater than the number of users, so that we can take all advantage of massive MIMO property here, like favorable propagation, channel hardening, Hill array gain, and all things. So we can obtain huge benefits of cell-free massive MIMO. More precisely, it can provide huge spectral efficiency and energy efficiency with very simple linear processing, like zero forcing, because of the multiplexing gain and array gain, because now the number of checkpoint, or actually the number of totals antennas high array gain and multiplexing gain here. Another important thing actually is the most important thing of cell-free massive memory, that it can provide high coverage probabilities due to macro diversities, because you can see that as point now are distributed in the large area, so we have very high macro diversity here. So whatever the location of user is here, you can see around several access points we can serve that user, right? Therefore, it can provide uniformly good quality of service for all users in the network, ensuring everything and everywhere connected. So this is the important thing, equally connected, because the connectivity is one of the key requirements for the future wireless network. Okay, so that is just the basic of cell-free massive memory. Now I would like to focus mainly on the topics of today, so about the physical layer security aspect in this system. So again, in this talk, I will provide two different scenarios. The first one is cell-free massive memory is under attacks of inactive eavesdroppers, and another system with that cell-free massive memory is unavailable, which is applies for surveillance system here. Okay. So we start with the first system first self-read massive MIMO under active ePropers. So here is the system. We have L's access point. It has M antenna here, and we have K user. It has a single antenna distributed in the areas, and there is one eProper attempts to intercept the information of one of K user. So here we assume that user one here. User one is the user's eProper one to overhear the signal. Okay. So to do that, if we use the pilot spoofing attack schemes, this is the most powerful, one of the most powerful scheme it can do to overhear the system, and we deal with this kind of system. So the worst case scenario in physical layer security here. Okay. So we show you later on how it works actually. So so you know that in self-read massive MIMO, time division the place is preferable. It means that it's coherent interval. So this is coherent interval. It's divided into three main activities: the uplink training, uplink data transmission, downlink data transmission, right? So here in this talk, we will focus on the downlink data transmission. So the uplink data transmission will be neglected here. So we have two phases: uplink training and downlink data transmission. So in the uplink training, so all users will send orthogonal pilot C1 to the access points. Then the access point will estimate the channel to all users based on the received pilot signal. Okay. So then the channel estimate at each access point will be used to create the beamforming vector or pre-coding vector. Then we can send a signal to all users. So more precisely, so look at the access point L. Okay, access point L. So this is a signal transmitted from access point L here. So it is a summation of all signal transmitted to all users. So we have K here. So SK here is the symbols intended for user K. Sorry. And WLK here is actually the pre-coding vector or the beamforming vectors depends on the channel estimate. So we estimate channel in this phase, and we use the channel estimate to create a beam so that we can beam to that user. So we have we can think that like we create K beam to K user, so the beam can be created by using the channel estimate. So when we know the channel to user, we can create a beam to that user, right? But of course, we don't know the perfect channel. We just estimate the channel depending on the quality of channel. Maybe our beam can be correct or not. Okay. So based on this one, it can conduct pilot spoofing attack. So more precisely, so during the uplink training phase here, because if want to overhear signal transmitting to user one, right? So then it will use the same pilot as user one during uplink training phase. By doing that, it can interfere the channel estimation up between the access point and user one. More precisely, so this is the channel estimation between access point L to user one, right? So it will be equal to the two channel. The two channel is the channel between access point L to user one here, plus the channel to if as well, because if use the same pilot, so at the end the channel estimates to user one actually combine two channel, to itself and to if. So we know that access point A, we use this channel estimate here. We use this one to create a beam, right? It means that actually when it beam to user one, is also beam to if, because actually this channel estimate is contaminated. Therefore, it create two beam, one beam to user one and one beam to if. As a result, if can effectively overhear the signal transmitting to user one. So that That is very critical issue. So it's very challenging to deal with this if when they conduct a pilot spoofing attack actually. So now our main task is how to deal with this scenario, how to reduce the performance of overhearing performance of if here. So we propose two methods. The first one is asset point selection scheme, and another one is power control scheme to guarantee secure communication in this scenario. Okay. So the asset point selection, so just a very simple idea actually. So just look at this figure, for example here. Let's assume that this asset point 1. So they're very far from user 1, but they're close to if, right? So if asset point 1 transmits signal to user 1, then the signal received at user 1 is not very strong. At the same time, the signal received is strong, right? Therefore, if asset point M sends signal to user 1, with high probability, this can overhear that signal. Okay, but look at this asset point. So this asset point L here is very close to user 1, but it's far from if. Therefore, if we send the signal to user 1, the information leakage to this one is not very strong because of the path loss is very far here. So it means that we should asset point 1 should not transmit signal to user 1, but asset point L should transmit to user 1, right? So basing on this observation, we propose a very simple 3D large-scale based asset point selection scheme. We choose a group of asset point, not all asset point, to say the user 1, depending on the quality of the channel between asset point to user and asset point to the if, right? Okay, so that is, I just want to provide the general idea, not want to go to detail here. And for power controls, because you can see that each asset point will send different signal to different user, right? So we have many degree of freedom in terms of power here. So let's take a look at again the formula we have before. So this is the signal transmitted from a and this beam is weighted by the power control coefficient here. So this is the powers allocated to a given beam to a given user, right? So we have L as a point and we have K user. So in total we have K times L. So parameter here we can optimize because we can control the power to reduce the interference between the user and to reduce the overhearing capacity of the if as well. So we formulate an optimization problem which choose the power control coefficient to maximize the SNR of user 1, because this one is the user is attacked by if. Given some constraint, some quality of service constraint of all the users, so all the users have to be greater than some quality of service requirement here. And this is a constraint on the performance of if. It means that this cannot be smaller than this threshold, okay? And this is the total constraint at each asset point. So each asset point has some limit power here, right? So we have constraint here. So this one can be solved by using some optimization tool. I will not go there here, but just want to show you the benefits of our proposed scheme compared to the benchmarks by looking at some numerical results here. So this is a simulation setup with just an asset point distributed in areas of dimension 1 kilometer and 1 kilometer here. So these are the basic parameters we choose from 3 GPP, and then we for the last scale the power loss and cycling here just follow 3 CPP model for macros network actually. And this just shows the results. Just I would like to come to see the benefits of both classification scheme first. So, so this shows the secrecy, spectral efficiency, and percent of numbers answer point L here for two schemes. So this is the answer point selection scheme. It means that we choose a group of answer point to serve user one, not all. And now answer scheme is the one we know. We just all answer point we serve user one. Okay. So you can see that quick answer point selection scheme, the secrecy efficiencies improve significantly compared to answer point selection scheme, right? For example, it can increase like 3 times, right? Even 3 times or more than that actually from this numerical result. And this showed decent benefits by using a decent optimal power control as well. So we have asset modulation and optimal power control. So we compare with the case with asset modulation and eco power control. So eco power control is mean that we the power to all users are the same. So it means that we use the same power to different users. We don't do any optimal power control here. And then you can see we obtain also a huge improvement like 150% here. So by combining asset selection and optimal power control, we can improve the system performance significantly. So we can compare with this case, no asset selection, no power control here. So it's like 5 times better. Okay, so that gives you a graph ideas of the benefits of both asset selection and power control in terms of secure self-massive memory, where the system is attached by an active developer here. Okay. So the asset selection now you can see very simple method, but it works really well here. Okay. So that is for the system where self-massive memory is under attack by an active if. So we move to a complete different system where now self-massive memory is an if proper actually is. So this is applied in the surveillance system. So we have K untethered link. So transmitter, receiver. So we have K link here. Each one they are untethered. So we would like to build a monitor to monitor K untethered link here. So how to do that? We propose to use self-massive memory system where many asset point distributed in large area to monitor the system. Okay, the reason to use self-massive memory is that because it offer very high degree of freedom. As point distributed in many areas. As the result, we can build a robust system we can monitor if effectively the K here. Okay, so regarding the location of the link, we still have some asset point to monitor, right? So we propose proactive monitoring methods to build the system here. More especially so there is a group of asset point, the green one here, which are in the receiving mode. It means that this green asset point will overhear signal from K undoubtedly. Okay, and another group of asset point, the blue one here, will be in the jamming mode. It means that this asset point will transmit jamming signal to untethered links so that it can reduce the performance of untethered links. As a result, it can improve our monitoring performance, right? So your question here is for a given system setup, how to choose which asset points are in receiving mode and which asset points are in jamming more so transmit jamming
Sorry to
signal to
interrupt, sir. I'm sure all the
yes.
participants are enjoying your talk, but we have time constraints, so I request you to kindly wind up in another 5 minutes. Thank you.
5 minutes, okay, I have time, just don't worry. Yeah. Thank you. So okay, so the question is how to choose which access point for in this receiving mode and another one in jamming mode, right? So in addition to that, when the access point in the jamming mode, it will transmit signal to different to optimally control the power as well. So then we propose an optimization problem which to the remote assignment and power control to maximize the properties for monitoring. Okay, here we will choose which point are in the receiving mode and which are point in jamming mode. And also we will choose the maximize one given on people. So this one can be solved by using iterative algorithm. It means we fit the power control, we optimize the mode assignment, and then we have mode assignment with optimal power, and so we do it iteratively. Okay, I will skip it as well here. So also would like to show you the numerical result to verify the benefit of a proposed scheme. So this one is more probability, the number of antennas, the case location, and this is short location. So this means that this scheme with asset point mode selection and power control. So we can see that it significantly improve the performance of monitoring success probability, right, in terms with the case of resort location. The co-located system, we can see that the co-located massive memory means that all asset point we co-located in one area, so we have very big underlying already. So we can see as that self-massive memory is significantly better than co-located massive memory in terms of monitoring success probabilities, especially when you increase the size of the areas. The reason is that when the area is larger and larger, self-massive memory is more advantage in terms of connectivity, right? That we have from the theory. Okay, at this evening, so I think that's all from my side here. I just want to come to your conclusion. So again, I would like to emphasize that to ensure that well in this system, the only way is self-massive because it can remove the boundary effect, remove improve the connectivity. Okay, and self-massive memory can offer many degree of freedom and hence is very robust against active developers as well as is a powerful technology for surveillance system. Because many are small distributed in the areas, we have many degree of freedom there. And of course, this is still a new topic. There are still many research direction here. Like we need to use here within on interference calculation technique. When we jam the signal and we receive signal at the same time, we have the interference. If we have powerful calculation techniques, we can improve signal performance significantly. Or we can do currently with iterative optimization, we can use joint optimization to improve the performance. We have some non-orthogonal pilot. We have some orthogonal pilots when we do trainings, but in general practice, if the number of users is large, non-orthogonal pilots should be used. So what happens for this guy is also interesting. So I think it's all from my side. One week's questions.
Thank you, sir, for such an enlightening session. If anyone in the audience has any questions, you may kindly unmute yourself. Seems like there are no questions. So now I would invite Dr. Anil Kumar Shukla to present a certificate to Dr. Incogno as a token of appreciation.
Thank you so much once again, Professor, for joining
Thank you.
SPIN2025. Hope we will see you in next spin also.
Yes,
Thank you
sure.
so much.
Yeah, thank you very much for that.
Thank you for being a part of SPIN 2025, sir.
Yes, thank you.
Now I would like to invite Dr. Shilpa Pawar. It is a great privilege to have Dr. Shilpa Pawar with us today. I would like to call upon Dr. Anil Kumar Shukla to present a sapling to Dr. Shilpa Pawar.
Yes, good afternoon to everyone.
Thank you so much, madam, for joining. Welcome
Yes,
to
sir.
SPIN2025.
Yes, sir. Yes, sir. Thank you for considering me for this conference. Hope I'm audible, very clear.
Yes, you are
Yes, ma'am.
audible, madam.
Yeah,
Dr.
thank you, sir.
Dr. Shilpa Devram Pawar is a distinguished academic and industry professional specializing in electronics and telecommunications. She earned her PhD from JJTU Rajasthan, focusing on an IoT-based remote monitoring system with secure data transmission. She completed her ME at Pune Institute of Computer Technology, Pune, under Savitribai Phule, Pune University. With 25 years of experience in academia and industry, including 13 years as an assistant professor at Army Institute of Technology, Pune, she has contributed extensively to research and innovation. Her industry tenure at Micromax Informatics Limited, Pune, involved work on RTOS and embedded projects. Dr. Shilpa holds patents for an IoT based asset tracking system and digital classifications using machine learning. She has an extensive publication record covering IoT, embedded systems, cloud computing, network security, artificial intelligence, machine learning, and deep learning. As a frequent speaker and conference reviewer, she actively contributes to the technical forums and professional communities. She has also completed certifications from prestigious institutes like IIT, Bombay, and NTPL. Once again, welcome, ma'am.
Thank you for such a wonderful briefing of my biodata.
Yes, ma'am. Ma'am, would you like to call upon the paper presenters or would you prefer if I did it?
No, you can call upon the present.
Okay, ma'am.
Yeah.
Starting with the paper presentations. Now I would like to call presenter from the paper ID 1 to present their paper. I would like to call presenter from paper ID 6 to present their paper. Let's talk on the sign here. Please start with
Paper
the
ID 6, we are there.
Yes, this is Saineha and Dr. Umadevi. We will be presenting on our behalf.
Madam, only one presenter is allowed actually. We will be able to give certificate only for one presenter who is already registered.
Okay, sir. Okay, sir. Neha, can you continue? I'll share the screen.
No, ma'am, I think you should continue.
Yeah. Okay, I'll continue. We are the two authors, sir. Anyone will present and anyone you can issue the certificate, sir. No problem, sir.
Yes, madam. Thank you. Thank you so much.
Sir, my screen is visible. I have shared the PPT.
Yes, it is visible. Make it in slide mode.
I have done it, sir, actually. Slide mode.
Yes, now it is visible.
I'll continue with the presentation, sir. Okay, thank you. Myself, Dr. Uma Devi. I'm a professor in Computer Science Department, BMS College of Engineering, Bangalore. My co-author, Sneha, she is a student at Mahindra University, Hyderabad. Paper ID 6. We are here to present our paper on the topic analyzing the performance of sampling techniques on the imbalanced data sets. Going to the next slide, this will be our table of contents. Now, what is imbalanced data sets? That is, when we take any data sets actually, that is data set there will be imbalance between the labels. For example, here we can see that is label 0 is having very less samples when compared to the label 1. Or when we take binary classification, that is negative samples may be very less, but positive samples may be more actually. This type of imbalanced data sets will occur in many applications like medical diagnosis, fraud detection, manufacturing, text classification. Almost all the applications will be having this type of data sets actually. That is, we are looking in this particular paper actually how we can use this, balance this particular data sets actually so that we can get a good classification accuracy. That is, sampling techniques are actually, where there are many sampling techniques. We will tell what we have explored actually. That is, they try to balance between both the positive and the negative classes actually, either doing undersampling or oversampling actually. This figure, what it shows is an oversampling where it increases the number of label 0 samples to almost equivalent to the label 1 samples. Now, in this paper, what is our objective actually is that is to assess and analyze the different sampling techniques using different models of classifications with regard to the imbalanced data sets. For that, we have chosen the 4 classification algorithms: key nearest neighbors, decision trees, random forest, and logistic regression. And sampling techniques, what we have explored is that is undersampling, oversampling, and then Tomlin's weighted sampling and EMS. That is, we just took the existing algorithms and the existing sampling techniques, and then we try to explore these things on this particular 4 data sets which were imbalanced actually. This data sets we have taken it from the KEE repository, that is Glass 1 data set, and then PIMA, wine quality, East. All are binary class labels, only 2 class labels were there actually. And now the imbalance ratio, what we have identified in this one, that is it is in the Glass data set, the ratio was 1.8, and PIMA it was 1.87. This ratio tells us what is the difference between the positive and negative samples actually, number of instances. And we can see that is in the wine quality data set, the imbalance ratio was very high, and in East we have 9 actually. Now, this is what the methodology we have came up with, that is to how we can analyze the effect of the different sampling techniques on the different this thing. That is, we took the data set, first we pre-processed in the sense that is, we did for the class labels which were in the categorical to convert it into a numeric actually, and split it the data set into the train and the test actually. And then we took the 4 algorithms, decision tree, random forest, key nearest neighbors, and logistic regression. And then we evaluated that one. And the sampling techniques what we have applied for all the 4 data sets are oversampling, undersampling, SMART, near miss, weighted, sampling, SMART, and we did the combination of SMART and then the Tomlin's and then the Tomlin's actually. And now coming directly to the result analysis of the class 1 data set actually, that is in this one you can observe actually that is when we applied the 4 classification algorithm with all the different sampling techniques, and also we did the observation without sampling also actually. And the metrics what we have this thing is observed was accuracy, recall, precision, F1 score and AUC score we have done. That is, in this one we can observe that is for the random forest, when the SMART, that is synthetic minority oversampling technique, when we have applied SMART actually, it gave the best results when compared to the other this thing. Our objective of the paper is to do the analysis of the different sampling techniques for different data sets which are imbalanced. And next, when we went with the PIMA data set, that is, which was a diabetic data set actually, that is, in this one, we have observed that is the decision tree was giving little better, but not good, but SMART was giving better results when compared to the all other sampling techniques combinations. And next, when we observed the result analysis with respect to the wine quality data set, actually, that is for the wine quality without any sampling techniques with the existing data sets, actually, that is whatever the instances we had, actually, random forest regression algorithm was giving better results, which is around 96 actually, when compared to all other data sets, all other sampling combinations. And the last data set, actually, that is the East data set actually. Once again, yeah, the random forest algorithm gave the better results with respect to the SMART actually when compared to all the remaining observations. Actually. That is what we try to conclude from this particular work is that is, as I said, we took four imbalanced data sets and four classification algorithms and the combination of the sampling techniques actually. That is for the glass one data set, the random forest classifier when coupled with the SMART sampling technique yielded an optimal result of about 90% accuracy. And for the PIMA diabetes dataset, decision tree algorithm, when combined with the SMART, produced notable result, but not, as I said, in the results, it was around 77% accuracy we got actually. And for the wine quality dataset, the logistic regression approach was giving better results along with the combination of the SMART and TOMK combination sampling techniques, which was around 96% accuracy. For the East data set, actually, the random forest classifier along with the SMART technique gave the results of around 99.02 accuracy. That is, in summary, that is utilization of the sampling techniques when combined with the diverse combination of the classification algorithms will give. That is, we didn't observe that is the same sampling technique may give the better results for all types of data sets. It varies actually. Therefore, for that particular, if we have any data set for the general application, we have to do the experimentation with the different sampling techniques, and then we have to work out which sampling technique will give the better results. This is what we have observed for this particular four different imbalance data sets actually. This is from our end actually. This is which was a gist of our paper actually. Now, these are the few references which we have listed here. And now this is thank you for the organizers, and I'm open to question. I just kept it a very brief description of the paper. If there are any questions, I'll further answer to it actually.
Yeah, hello, ma'am. Ma'am, I just want to ask the data set which you use for imbalancing, from where you got this data set?
Madam, it is from the KEEL repository, which is there actually. Under that one, we have taken, and in the reference of the paper, we have given a link to that particular data set.
Okay, you have taken from Key. Okay.
Yeah.
You said that your output is better when you have done the balancing of the data set. So, where this output of your data set will be used?
In a sense, what was our observation was that is like we wanted to analyze the combinations of this one. For example, say when we want to apply the say wine quality itself, actually wine data set which has to be classified whether it is a good wine or not a good wine actually. In that type of application, what we are trying to tell the logistic regression algorithm along with the combination of two sampling techniques was giving better.
Okay. Because the Keel, you're saying, the Kaggle, you're saying there are so many data sets available already in the market for medical purpose and everywhere. So once your paper is implemented, so in future, how you see your paper's implementation?
That's what, like in real time, if we get any medical data set, actually, for example, say Indian diabetes data set, actually, at that time, we can apply this particular sampling technique, which we observed, the SMART plus TOMK link, which was giving a better result, actually. That, along with the logistic regression, may yield better, actually. We took to the application, we used the existing data sets and we did the experiments, and whatever the observations we have got, that we have discussed in our paper.
Yeah. Okay. Thank you, ma'am.
Thank you. Shall I stop sharing the screen?
Yes, I believe there are no further questions from the audience.
Okay then.
Thank you very much,
Thank you.
Dr.
Thank
Ovela.
you.
Now I would like to call paper presenter from the ID 1, Tia Sarkar. Mr. Tia Sarkar, are you here? Can I visit next week? Okay, now I would like to call presenter from the paper ID 16, Salabatullah Sayam Varg.
A very good morning to everyone. I am Talabatula Shamar Prasad. Sir, if you allow me, can I present my screen? Hello.
Yes, please share the screen.
Sir, is it visible?
Yes, yes, it is visible. Please make it in slide mode.
Okay, sir. Yep.
Yes,
So, first of all, thank you to Amity University from Noida providing this such kind of researchers and encouraging like students from my side. So, my project is about application of deep learning algorithms for land use and land cover change detection. So I am Talabatula Shamar Prasad and I am the presenter today. And my co-authors P. Sara Suhasni ma'am, who is an associate professor at the Department of EC from BRSCC, and Karthik and Sandeep are my co-authors. So coming to the next slide. So the context of the project is we are focusing on the Indian dataset, Indian satellites, which is resource at one we have considered in this project. So it is available at Bowen NRSC website, and it is free to available, and any researcher can use. So we have considered the Indian dataset as it was not used by any of the research that currently on. So the main theme of this project is to find out the land use and land cover changes in the particular area. So the area will be in the Nujvido is the research area. So we have used three types of machine learning models. One is clustering algorithms and ResNet. So next, our aim is to implement these deep learning and machine learning projects and algorithms in land use and land cover transformation and how they react in the spatial or spectral information. So this data set is from Nojvido in the Bowen NRSC website, which is an multispectral data. So consists of four bands B1, B2, B3, B4, and B5, which is green, NIR, SWR, and red bands respectively. So in this project, in this presentation, I am going to discuss about k-means clustering and fuzzy c-means clustering along with ResNet classification comparison that we have done in our project. So next we have, first of all, if we look into the background of the land use and land cover analysis, in the earlier methods we used it to do manual inspection by uh, going into the research area and collecting all the information like that, and using those data and implementing in the statistical models. So it will be more complex to analyze, right? So next thing is we in 1970s to 1990s. So the deep learning models and I'm sorry, the component analysis models and all this stuff like coming into the picture, that is image processing. So it became a bit easy compared to earlier methods. So next we have known to be pixel-based approaches. These are used to detect in an image of pixel and compare it to the desired classified uh, class of something like dense forest, agriculture, etc. So next one is machine learning advancement. In the early 2000s, we have entered into algorithms at numerous number of like SVMs, random forests, and regression, logistic regressions, linear regressions, etc., which opened a door to the deep learning models networks. So I'm going to explain about ResNet and how ResNet have implemented in our project. So to be short, I will proceed to next one. So first one we are going to see about data pre-processing. So how we have uh, pre-processed the data from the Bhuvan NRSC website, that is raw data. So we have first of all to in the uint0 format. So that was converted into .tif, and then we have stacked the three bands that we have seen majorly consisting of some classes like dense forest, agriculture, shallow water body, and narrow water body, etc. So those bands are near IR, red, and green. So to form a FCC imagery, so those FCC of 1153 by 1153 by 3 size image, so that was patched into a 100 by 100 by 100 by 3 to train the ResNet model. So uh, those images were from 24th October 2009 to 5th May 2019. So each six classes has every 200 images for training and testing. So this is the approach. We have considered the each color to the each classes. That is dense forest is dark red and vegetation light red. Agriculture pinkish red, as you see in this slide. So we have considered the hex codes for each color, and they have mapped with the classes we are going to classify, and those are implemented in this clustering algorithms and deep learning model like ResNet. We have clubbed the classes like according to these color codes. We have prepared the data set for ResNet. Next one is the approach for k-means clustering with n clusters, that is six classes. So we have length of class RGB values that I have told previously that we have considered the hex codes, and each length of the hex codes are considered as cluster centroids, and using Euclidean distance after clustering, the Euclidean distance will be mapped to the desired color values, and therefore the segmentation will be processed. So same thing will be performed in the fuzzy sequence clustering, which is same like in the k-means clustering, that hex codes were mapped to the each classes, and the membership values will be assigned randomly using Python code, and we have obtained a segmented image as we have seen our paper. So next thing is about ResNet. So we have implemented the multispectral data of resource at 1 with list 3 sensor images, that is 1153 by 1153 by 3 bands, and we have patched each of 100 by 100 by 3 which of six classes having testing and training images of 200 each. So we have considered of 80% for training and 20% as testing, as we have seen in this slide. So at finally this ResNet architecture consists of 127 layers. So next we have going to discuss about results. So as I said earlier, the Bhuvan NRSC website provides open archive data, and any researcher can be used in their research. But here we have faced one issue is truth. The ground truth level is unavailability. So we have not considered the performance evaluation of the model. So as you see in the next slide, this table will tell us the classification in the each classes, that is in the k-means clustering. For example, dense forest occupies in the Nojibid patch area of 26.34%. Likewise, in the fuzzy cements also we have observed that same classification was done in the same clustering, and ResNet uh, performed a bit different here. So next, the k-means and fuzzy C-means clustering assigned each pixels to the nearest predefined class RGB values that we have discussed earlier. That pink red, for example, a forest area, or a dark red for agriculture area. So the why is it red always? Because in the false composite image, the green light in the chlorophyll will reflected back as the red color in the infrared electromagnetic spectrum. So FCM is a soft clustering, and KMS is a hard clustering method. So using ResNet, we can obtain uh, a deep clarity image in the network flow, and we cannot lose any of the details in the spatial information, right? So, and next one, the clustering methods will struggle to gradual transition in the land cover, while ResNet could handle them efficiently, as we have implemented in many of the image classification networks. So, in the next slide, so this is the bar graph that totally compares of each classification
Sorry to
in the
interrupt, but
table mentioned.
we are in a time constraint. I would like to request you to kindly wind up in 2 minutes. Thank you.
Yeah. Okay, sure, sir. Okay. Uh, I am ending with this conclusion slide. So you can LUSC changes with the combination of K-means and FCM clustering methods along with ResNet. So we have considered here like clustering methods are 26.34% identified as dense forest and 30.26% under ResNet performance. But here, even if ResNet consists of skip networks, the gradient descent will be minimized, but we are unable to find which is correct one. So we have working on the same data even now. So the unavailability of ground truth in the resource at one multispectral imaginary challenges in comparison between clustering methods and ResNet model. So this research encourages not only the Indian resource set data one, also the urban management and agriculture development using this LUSC change detection. So this is my presentation overall, and thank you for everybody for your patience.
Thank you very much. If anyone in the audience has any questions, you can unmute yourself.
Yeah, I just want to know that how you have implemented your oral project, like this session, this paper. That what tools you have used for that?
Ma'am, first of all, very good morning, ma'am.
Yeah.
And
Good
the
morning.
tools we
Good
have used
afternoon.
is yeah, ma'am. Good afternoon,
Yeah.
ma'am. The tool we have used is Jupyter Notebook, and the programming language is Python. The TensorFlow and Keras for the frameworks we have used in this project.
Okay, in Jupyter only you use the TensorFlow.
Yeah, ma'am.
Okay, fine. And how you got the coordinate for land use and land cover? I think you have used a data set for that, no?
Yeah, ma'am. The coordinate for this is a 80.65 degrees north longitude and 16.75 east longitude. Latitude, ma'am.
Okay. Okay. Thank you.
Yeah, thank you, ma'am.
I believe there are no further questions from the audience. So now I would like to call the presenter from paper ID 1 to present their paper. Priya Sarkar.
Excuse me, sir. Sir, can I stop sharing my screen?
Yes.
Yeah, thanks.
Thank you very much.
Thanks.
Mr. Tia Sarkar. I believe they're not here. So I would like to call the paper presenter for paper ID 61, R. Kavin Kumar.
Hello.
Yes, you are visible.
Can I share my screen now?
Yes, you can.
Am I audible?
Yes, you are. You can start with your presentation. Thank you.
Okay. Good afternoon, everyone. I'm R. Kavan Kumar. I am one of the authors and the presenter for the research study Accelerating DNA Sequence Alignment using Optimized AI Techniques. Now, before I dive in, I would like to let you know what we'll be looking in this presentation. First, I will give you an introduction of what genome sequence alignment is. What is the problem that we tried to solve in this study? What previous studies have been conducted in this domain? What are the data? What is the data set that is being used? What methodologies we have used in order to solve this problem, and the results that were obtained upon conducting this study. So to start off, what exactly is genome sequence alignment? Now, genome sequence alignment is a technique which is used in bioinformatics where two or more sequences are compared with each other to identify the similarities and differences between them. Now, how this takes place is that let's take an example of four letters, say A, T, C, and G, which are the proteins, and say there's a second sequence A, C, C, and G. Now, there's a difference over here where the T and C in the second position do not match. In this case, the total alignment score comes out to be 3. So this sequence alignment is performed in order to understand the structural, functional, and evolutionary relationship between sequences. Now, why this is important is that it helps us understand. Let's just take an example of a human and an ape. When we compare the genome sequences, 98% of the sequence is similar, but then the rest 2% is different, which makes us which makes up for the human intelligence or the human bodily functions. Now, apart from specific evolutionary relationship studies, it can also be used for disease prediction as well as drug discovery. Now, traditional genome sequence alignment is conducted using various tools, and one of the most famous tools is BLAST. But at the core of this, they are performed using two techniques. One is global alignment and local alignment. Global alignment is when the entire sequences are taken and compared with each other, and local alignment is when a specific region of the sequence is taken and compared with other regions. Now, global alignment is what we'll be looking at in this study, and global alignment is necessary specifically for evolutionary studies, but again, it can be further extended into other domains as well. Now, there's an algorithm called Needleman-Wunsch, which is based off of dynamic programming, and that is the model or algorithm which is used in order to perform optimal sequence alignment. The issue, however, that arises with this is that it is very computationally intensive, and for larger data set, it gets worse. Now, why we need efficiency over here is that while this is very important, but this process of sequence alignment is very important. Currently, alignment takes place with the use of supercomputers, and it cannot be used for real-time application. So it's a long process, and bringing in efficiency over here will help improve the overall system. And why we need ML in this is because it can help substitute this process of linear alignment for each individual letter, and instead allow the model to make predictions between the two sequences. The problem that we have tried to solve in this study can be broken down into three main objectives. One we try to improve the alignment accuracy. Two, we have to reduce the computational time without sacrificing performance, and we're trying to improve the scalability and hardware efficiency. So prior studies have been conducted in this domain, and we have taken up four main studies which we felt had the best impact in this domain, specifically with respect to AI techniques being integrated into this domain. First is our base paper, where this is a paper over which we tried to optimize and improve our study, and they used an NLP based model with an Adam optimizer, which managed to perform 99.7% accuracy. However, the issue that arises with this specific study is that the values of the performance metrics which were achieved were not persistent across all devices and across all data sets. So it kept fluctuating. We conducted the same study, 8% and 99.7%. But however, 99.7 is listed in the paper, so that's what we're giving up here. They've also gone into other different models like SVM, XGBoost, naive and K-nearest neighbors, but the average accuracy came out to be somewhere between 40 to 60%. Other studies have involved using methods like neural networks, random forest, and Hadoop's MapReduce framework, and they, however, fell short in terms of obtaining the highest accuracy, or they cannot be used for real-time use cases. The one different study which was conducted, you had used the hidden Markov models, but again, it fell short with respect to how it can be used in real-time application. It was just an experimental study at the end. Coming to the data set, this data set was taken from the previous study itself so that we can show you a direct comparison. And the data set was found on IEEE data port via their paper. Now, to give you a base understanding of how what the data set is like, so a DNA sequence consists of 4 proteins, A, C, G, and T. And these are the core building bodies of each and every cell and each and every organ in our body. Now, the frequency of the data, the frequency of each of these proteins from the DNA sequence has been plotted here, and the data set has been processed in a manner as shown in the image given below, where we've taken up, where we have encoded these values and have broken down each of these sequences into sets of 8. The nucleotides have been encoded in their binary and decimal formats, and this table shows you the specific encoding, and this has again been translated in the data set and used in final labeling. Now, in the data set, there are 254 different class tables and 16 different feature representation or input attributes. And we've used 2 different data sets over here, one unscaled and one scaled value, where the number of instances for each of them have been listed here. So, getting into the methodology which we have used, the first comes the data collection process. Now, the data can be found on any. The data can be found on NCBI websites. It's just the raw data with the protein sequence. Now, we have listed reference sequence and comparative sequence here, wherein the reference sequence is a much longer sequence, to which the smaller sets of comparative sequence are compared in order to figure out the similarities and differences. Then comes the data formulation process, where we perform a base layer of NW Needleman-Wunsch algorithm alignment on MATLAB, and then get in with the class labeling process. Now, the data set, the reference sequence data set is split up into 80% testing and 20%, 80% training and 20% testing data, and the comparative sequence is split into 20% training and 80% testing. Now, we've used 3 different models in this study, the CNN, BioLSTM, and random forest. Now, these models had not been previously used to the extent that it has been done in this study. Now, based off of the final performance metrics which were achieved, the model is chosen and has been output. Coming to the model as such, the random forest model, in this specific case, we had used 100 decision trees. The BioLSTM model, in this case, we had 2 layers of LSTM, where one had 200 units with returning sequence. The output is being given again to the input, and a final output layers with rectilinear activation function and softmax activation function, and a convolutional neural network where we had 2 layers of 3D convolutional layers and max pooling, adjusted pooling layers, and a dropout rate of 30%. And again, from the convolutional 3 layers gets flattened out into a one-dimensional vector, which is then used for analysis. Again, this uses output layers with rectilinear activation function and a softmax function, and we've used atom optimizer in both these cases. Coming to the results that we had obtained, it was seen that the CNN performed best with obtaining 99.97% accuracy, and it got a training time of 1,604 seconds, which improved on the existing study by a factor of 2.5. And it was seen that the random forest obtained 237 seconds, and it improved on the existing model by a factor of 20%. Now, the reason why we use these models is that the CNN and BioLSTM models help perform in terms of help classify these sequential data, where the CNN was able to localize these patterns which are already existing, such that the prediction can be made quicker. Now, the random forest, yes, however, it has a lower accuracy in terms of marginal requirement. It was used in order to improve the computational efficiency, such that it can be used in a real time. It can be used in a real time application. Now, here is a plot that we have visualized over in order to understand the comparative summary, and it can be seen that the CNN bialistic models outperform the existing MLP model. Now, coming to the training time and testing time, the random forest had the least lowest training time, and the MLP, however, does have the lowest testing time. But again, in the real-time use case, it doesn't. There's a very marginal gap, and the reason we're focusing more on training time is that the reference sequence initially has to be trained in order to compare it with the other shorter sequences. So, allowing models such as random forest to be able to perform in with such fast-paced timings allows a direct application wherein you can just input the data and receive an output rather than having to wait for like 32 hours for the process to get done. Now, for the scaled data set, it was seen that the performance remains persistent across all the various different models, and there were variations of plus or minus 0.03% across these models, depending on the data set. Now, the scaled data set is essentially the data set which has been doubled and has been randomized in the order. Coming to the hardware usage during training and testing, it was seen that the CPU usage is very minimal, which suggests that it can be used across various other devices and low-end devices as well. And coming to the memory usage, it was seen that during the testing process, the memory usage was comparatively higher, just as it's trying to figure out the localized patterns. And again, this can further be improved by parallelization, but that was not the main focus of it, so we just left that. And in terms of the GPU load, there was barely anything. So since it's working on continuous sequential data. To conclude the presentation, the proposed methodology was able to achieve 2.5 to 20% faster execution times, and the model remained persistent across different devices. The CNN model was able to provide the highest accuracy with balanced computational efficiency, and the bialistic performed similarly but required longer times. And the random forest, though slightly accurate, provided much faster training and test low computational times. Now, the main thing, the reason why we used 3 different models over was that we would be able to we'll be able to execute these across 3 different across all different scenarios wherein we have a larger data set but we need shorter time, or we need more detailed where we need more detailed explanation of each of these, or we need more detailed performance methods. Now, coming to the future scope, this study can further be improved by integrating transformer-based architectures like BERT and BioBERT. However, their main focus is on biomarker detection rather than DNA sequence alignment itself. So, given that biomarker detection and DNA sequencing are integrated, BERT and BioBERT would be a great integration into the study. Apart from that, this can be expanded and made into a full-fledged application that can be used for personalized medication, and it can be again further improved by using hybrid AI approaches with new and upcoming models. And these are the references which we had used, and that's it. Thank you for your time, and thank you for this opportunity.
Thank you very much for your presentation. If anyone in the audience has any questions, you may unmute yourself.
Yes, just show me your conclusion slide. Yeah, you have taken these 3 methods, no? What is the reason of taking this 3 method into consideration, not the other one? There are many methods, no?
CNN, bialistic, and random forest?
Yeah. CNN, then.
The reason was that the thing is, when compared to the previous studies, where yes, neural networks have already been tried and tested, but they tend to fall short. And the reason why specifically CNN and bialistic have been used here is that the DNA data is very sequential in nature. So going for something like a bialistic model allowed for forward as well as backwards tracking in order to figure out in order to predict the different patterns which are underlying. And CNN, it helps you identify the local patterns within the entire data set instead of going through it sequentially from top to bottom. And the reason for random forest is that we were trying to look for a very traditional model, or like a very simple model, which can be extended onto any device and would not require something like a GPU or on low-end devices to be run. So, given that if a standalone device were to be made, the random forest model can be dumped into that specific code and can be used to test the real-time use cases within like 4 to 5 minutes, rather than waiting for like 30 to half an hour or 2 hours and so on.
Okay, good answer. Answered my question. And one more thing, you have done all this implementation in Python, I think, right?
Yeah.
Can you do this in MATLAB also, or any other tool can be used?
We can use MATLAB. For example, this data set alignment process, data set alignment, which is the Needleman-Wunsch technique. Now, the base of this alignment can be done on MATLAB, from which, like, from this data set as a preprocess. But again, this entire system can be implemented on MATLAB itself, given that we change up the model, we tune the model in a certain way.
And plus, it has many inbuilt functions also, like compared to Python. Is it that way?
Yes, the thing is that the Needleman-Wunsch algorithm has its own built-in library in MATLAB. However, it does not predict, or it does not exactly substitute this process of linear alignment. So again, when we go to MATLAB, it only increases the computational time, or it does it like manually, and that sort of increases computational efficiency and like time, or like it's just overall effort which is put into it.
Okay, good. Thank you.
Thank you.
Thank you very much. And now I would like to call the presenter from the paper ID 1, Tia Sarkar. Please present your paper.
Hello, sir. My name is Tias, and
Yeah, you may share your screen.
yes, sir. This is my paper, sir, and
also, please turn on your video.
yes. Am I visual, sir? Hello, hello.
Can you show your ID, please?
Paper ID 1.
Your ID on video.
Can you please show your identity proof? And also please turn on your camera.
Yes, ma'am. Am I visible?
Please show your ID card.
You may proceed with your presentation.
Okay.
Keep your video turned on. Right?
Okay. Yes, ma'am. So it's based on air quality tracking for smart city management, and for this we have considered 4 major cities, which is Delhi, Kanpur, Lucknow, and Jalandhar. And this is the introduction part. For literature review, we have considered 5 authors, and here is a proposed methodology.
there some issue? Mr. Tias, is there some issue? I think there's some technical issue, so we will be proceeding with the next presenter. So, presenter from the paper ID 71, the Lasya Priya, the Miss Lasya Priya Bhardwaj. Paper ID 71, Miss Lasya Priya.
Yes, sir.
Kindly turn on your video and then you may proceed with your presentation.
Hello, am I audible?
Yes, you are audible. ID card. Kindly show your ID card once on the video.
ID card.
Okay, okay, fine. Please continue with your presentation. Thank you.
Okay. Um, Good afternoon, everyone. So I am Lasya from Amrita Vishwavidyapeetham, and I'm here to present the paper which we worked on, named as Drug Discovery for Mycobacterium tuberculosis, a synergetic approach using QSAR and machine learning. Moving on to the contents that we are going to discuss throughout the presentation is introduction, problem statement, literature survey, and the methodology that we have implemented in our proposed framework, results and analysis, conclusion, future scope, and references. Now, for the introduction, as we know that drug discovery remains a critical challenge, especially for diseases like tuberculosis, diabetes type 2, malaria, hypertension, etc. We must recognize the fact that the traditional methods that we have employed in today's present day drug discovery are very costly and time intensive. Also, the organisms ranging from the bacteria to the human beings, we evolve as the human beings evolve. Even the pathogens, which are the bacteria that causes diseases, also evolve and become immune to the drugs that have inhibited them till now. The problem statement is to the main focus of this project is to develop a machine learning model to predict if the chemical molecule used in the drug development is a good inhibitor of the DHFR protein in tuberculosis. The literature survey. We have five main papers contributing to our proposed framework. The first paper is our base paper, which is employed and completely targeting the glucagon receptor for the diabetes type 2. And there are many limitations and improvements that are one issue is the data set, and they do not have the molecular docking simulations. The other one is they have to employ advanced genomic computational techniques, and for better predictive performance, most of the papers lack the So moving on to the methodology, now we see that there are two molecules on the left side. First, let us talk about the chemical compound being displayed here. It is the 2D structure, while Okay. Am I audible?
Yes, you are audible. You may continue, please.
As we see that there is a 2D structure in the left-hand side, there are two different molecules that are similar in structure, while the substitutional chain, which is the methyl group, is just different. For this 2D structure can be actually represented in 1D format, which is known as canonical smiles, which we will be discussing in the data acquisition part and the cleaning part. The data acquisition part and the cleaning part consists of the canonical smiles, IC50 value, and the labeling process. So IC50 value is a value which says how much amount of the chemical is required in nanomolars to inhibit the pathogen 550%. Now labeling is done based on the IC50 value. The lesser amount of the drug required to inhibit the disease, the better is the drug. Now the next process is to data pre-processing. And also the data collected is from the Campbell data, and it is divided amongst three active groups named as active, inactive, and intermediate. Active groups says that the IC50 value is less than or equal to 1000. Inactive is the IC50 value which is greater than or equal to the 10,000. While intermediate are those values that lies between 1000 and 10,000. The features from this data preprocessing is that the molecular Campbell ID, canonical smiles, standard value, and bioactivity class, which is active, inactive, and intermediate. The intermediate class is dropped because they do not mainly contribute in our model performance. Now, going to the data analysis, which are Lipinski descriptors. These are the attributes that actually contribute to the chemical composition, which are the molecular weight, log P value, HBA, and HBD. HBA and HBD are our hydrogen bond acceptors and our hydrogen bond donors. Molecular fingerprints are technically these 1D converted into the are computed using the paddle descriptor, and the number of fingerprint descriptors that we have, which is the binary format in the left side, is the molecular fingerprint. So that one is the number of fingerprint descriptors are 881, and we use variance threshold method due to the similarity between the molecules referred in this image, that the methyl, as soon as the position of this methyl group changes in the second molecule, there is a slight difference even in the molecular fingerprint. As we reduce so this helps us in reducing the dimensionality of our data set, ranging from 881 molecular fingerprints to 124 molecular fingerprints. Now, after this stage of data analysis, our features that have been selected are 124 features, fingerprints, and molecular weight, log P value, PIC50, and our bioactivity class. Later on, we use data splitting, which is our data split is 80% to 20% training and testing data set. The feature selection has already been done, and we use a lazy predict module which compares around 32 different regression models, and the evaluation matrix are R square, RMSE value, and the time taken. Now, after the lazy predict module has performed its after the module has completed its execution, we get to know that the best model is being gradient boosting regressor, and we apply our hypertuning parameters and cross validation as k-fold and grid search CV, and then test it again to obtain our final metrics of R square, RMSE, and mean square method. Moving on to the results and analysis, as I said in the beginning that we have divided the bioactivity class into three different classes which are active and inactive, and we are dropping the intermediate class because it is not contributing to the model performance. The active attributes are 625 and 363 out of the 988 chemical compounds that we have in our data set. The next part is where we show the correlation matrix and the scatter plot. Now, as we see through the scatter plot, the data is highly non-linear because we have 881 features and we can't separate it into different classes. Now, in the correlation matrix, we know that the values below 0.7 and above the highly positive values are being dropped. We see that HBD and HBA are being dropped because they have high correlation values. So our final feature selection would be molecular weight, log P, and PIC50 value. As we look into the box plots, these comparisons are the bioactivity with respect to our molecular weight, log P, PIC50 values. The active and inactive compounds are here onto the left side, and with respect to the log P is towards the right. And as we see into the bioactivity class with respect to the PIC50 values, we see that there is a clear linear separation between the two classes of active compounds and inactive compounds that are contributing in inhibiting the target protein DHFR. This is a visual representation of the R-squared comparison and RMSE comparison given by the lazy predict module that has compared 32 different models, and we see that our gradient boosting regression model is on a very higher note with respect to the other baseline regression models. On to the conclusion, now we look into the values that higher the R-square value, the better is the model performance and the least is the error. Now, when we compare the gradient boosting regressor with respect to the linear regression model, there is a large difference between the performance metrics of R square and of which is 0.4 and 0.09. And the error is pretty less. The future scope of this project proposed is that we can this project has been implemented only on the existing drug discovery compounds that has been used, and the chemical compounds that are being used for the drug discovery are limited right now. Now, in case in the future, if a person is trying to invent, say for COVID-19, people have invented a vaccine within a span of less time. Now, that would this would actually help in predicting the active and inactive compounds much before the molecular docking. Thank you.
Thank you very much for your presentation. If anyone from the audience has any questions, you may unmute yourself.
We are open for questions. Do anybody have any questions?
I believe there are no questions from the audience. So next move on to the next presenter. Now I would like to call the presenter from paper ID 72, Abhishek Sai.
Yeah, hello.
Yes, Abhishek Sai, you're audible. You should turn on your video and start with the presentation.
Yeah, sure. I hope I'm visible.
Yes, you are visible. Can you show your ID on the video?
Sure. Just,
Okay. Now you may share your screen and start with the presentation. Thank you.
yeah, okay. Thanks. Hope my screen is visible.
Yes, it's visible.
Okay. So today good afternoon everyone. Today I'm gonna uh, talk about a paper titled AI enabled tourism and an enhanced voice enabled bot for increased visibility. So today, right, like AI is transforming the tourism industry, like making travel experience more seamless and accessible. So with rapid advancement in technology, AI smart services are enhancing user experience, and more uh, making interaction more personalized and efficient. So one of the key innovations in this space is chatbots and voice bots. So chatbots provide text-based assistance, helping travelers find information, book services, and receive recommendations. Meanwhile, voice bots offer hand-free real-time interaction, which is particularly useful for travelers on the go. So these technologies also helps to overcome language barriers, allowing tourists to communicate effortlessly in foreign countries as well. So to address this need, we developed a dual model AI powered tourism assistant that integrates both chatbot and voicebot functionalities. This system is designed to provide seamless support to travelers through both text and voice interaction. And at the core of our system is an LSTM network model, which improves the conversational flow and context retention. And to enhance its multilingual capabilities, we integrated Google Translate, allowing real-time translation, and also this ensures tourists from different linguistic backgrounds can communicate effortlessly. And additionally, we implemented a speech recognition module to process voice inputs and then convert them into a text internally. And to use this, we used a text-to-speech module that converts text to speech back, and then entire interaction is like transmitted back as a voice. So coming to the workflow, so it's a simple workflow. So whether the system has two main groups. One is tourist and other is stakeholders. So tourist can use it to get instant answers about location, hotels, transport, attractions, or any other thing in the tourism sector. While stakeholders like hotel administrators, or resort managers, or whoever it is, so they can basically update travel information or any information. So this ensures to get like the database is latest and has more accurate details. So for tourists, the process is simple. They open the web page, choose their location and language, and decide how they want to interact. Like if they prefer typing, they can use chat mode, or they can use also voice. And so it's basically used for them to ask any queries, and then for stakeholders, the system works as a management tool. So hotel managers or whoever it is can log in, select location, then choose their category, choose their resort or anything, and then update information. And then this has saved in a centralized database. So which means that it like all the information is instantly available to tourists. So uh, so this in the this system, the impact of system is huge because for tourists it makes traveling easier by providing fast, reliable information in their own language, and for hotels and tourism business, it also helps them to manage and share updates effectively. And more importantly, it makes travel more accessible for people who struggle with language barriers or literacy challenges. And while coming to workflow of a chat module, so it is basically a workflow of how uh, the speech module is processed. So it starts with initialization, where system prepares to receive input. Then user speaks, and the speech recognition module captures and converts it to text. Next, the system is allows the user to select a preferred language, which is validated, and then it's the converted text is sent to a chatbot model, which retrieves relevant information from database. And once the response is generated, it is translated into a chosen language and converts into a voice. So, and finally, the system plays back to the response to the user. And to be more technical, the speech recognition module which you use converts voice into text, and then chatbot module which is trained on LSTM is used to like predict like which category and how is the query pattern, etc. And then chatbot generates a response. The system checks for a language, and then it's then passed to a Google Translator library and then translated back to a language. And after translation, the text is converted to a spoken words using Google text to speech API, making interaction more natural. And then using place on module, we basically try to play the audio response back to the user. And while coming to other LSTM model which we use, so this is the heart of our model, which is responsible for understanding and handling sequence of words. Unlike traditional models, LSTM can remember important information from earlier in conversation while forgetting less useful details. It has like majorly three gates. Input gate decides what new information should be stored. Forget gate removes unnecessary information, and then output gate determines the final problem stored. And then here dropout layer is basically added so that like to this layer randomly ignores some connection in networks during training. So this basically avoids overfitting. And then next, the information is passed to dense layer where a softmax activation function is used. And then this function helps classify input into different categories, allowing chatbot to understand the intent of user. And then finally, the output layer generates a chatbot response based on classification. So this is basically an architecture. And while coming to experimentation, so our dataset is basically a dynamic JSON-based dataset or MongoDB type of dataset. So it basically has each query has tags, patterns, and responses, making it easy to update in real time. And also this means that if a new information is needed, it can be added without changing entire system. And for dataset, it's divided into 80 training, 10 validation, and 10 testing. And then LSTM model has these four units: 512, 256, 256, and 123. And this LSTM model achieved 96.32 accuracy with precision of 0.934 and recall of 0.92. And this also has multilingual support and user preference. And the bot allows user to switch between languages like English or Telugu or whatever it is. This is a sample screenshot of how our a bot responds to user queries. And then while coming to the future work, we basically plan to include voice-based navigation, which means that tourists can get real-time GPS direction and suggestions for nearby attraction, which also helps travelers to explore new places usually. And also we will try to add sentiment analysis, which will be recognize emotion and response in a more friendly and useful manner. And yeah, thank you. That's all about my presentation.
Yeah, Abhishek, just go to your previous slide, Abhishek.
Yeah, ma'am.
Before that your okay. Oh, yeah. I just want to ask you that you said that you have used the Johnson-based dataset. So is it that Johnson-based dataset or this chat bot? Hi, welcome to our chat box. You have created that dataset, the data.
No, it's basically based on JSON.
JSON only. This model is also JSON. Can you means what you're saying? You're using the dataset, right?
Yes, right.
So what type of speech does that dataset has?
So this dataset, there is no any public available dataset for our use case. So we basically try to create one using different LLMs and based on users. Like we manually created a dataset. Yeah.
Okay, and this was the only dataset you have used. You have created and you have seen how the output is.
Right, because there won't be any public dataset, right, for this use case because it's not existing as of.
Okay, and what was the platform you have implemented all this?
This platform majorly it's on Python and basic of web development.
Python
Web development, basics of web development using, like front end
What
language
was
like
your
HTML.
okay web development? What is your front end?
It's basically based on HTML, CSS, and JS.
Which one?
HTML, CSS, and JS.
Okay. Okay. Thank you, Abhishek.
Yeah, thanks. Have a great.
Yeah.
If there are any further questions, you can unmute yourself.
Yeah, myself, Dr. Umadevi, I have a question. Abhishek,
Yes, ma'am.
you said you're trying the model using LSTM. Can you show me a sample data set actually? Like, what was your data set? It's in a JSON format, I agree, but what is the sample data set? Can you show?
Sorry, ma'am, I don't have in my current laptop. But it's basically like each would have three things. One is pattern, response, and tag.
Huh?
For each query, there would be three subsets. So one would be tag, one would be like pattern of questions, and there would be a response.
Okay, when the user asks the question, then how you will pull the data, like from these three columns?
So the pattern of the question, right? If a user asks some questions, we basically LSTM model is trained on pattern of question, how the pattern would be, right? So we can basically match like where the pattern is. For example, if a user has asked like what are the locations available on Hyderabad or any smart city, right? So we have a pattern of question like how user might ask it. So we basically like try to match it and then get the response back.
Okay. Okay. Yeah. Okay.
I believe the audience does not have any further questions. So, moving on to the next paper ID. Paper ID 1, TR Swarma. TR Sarkar. I believe there is some technical issue, so let us wait for 2 minutes for TR's paper ID 1. Let's just wait for another minute, and if they don't join, you'll end with it. Right. So I believe Diaz is not able to join. So the paper presenters are finished with their. So there was our final paper presenter. I would like to thank each paper presenter who presented their paper on their hard work. It was a truly fruitful experience. Now I would like to request Dr. Anil Kumar Shukla to present Dr. Shilpa Pawar a certificate as a token of our appreciation for being the session chair. Thank you so much, ma'am. Your presence really lifted the entire session's experience.
Thank you so much, madam, once again.
Thank you, sir.
Joining SPIN2025.
Yes, sir. Thank you, sir. I would also like to express my sincere gratitude to our esteemed speaker for the insightful presentation. Each one of you have contributed valuable knowledge and perspective, and we truly appreciate the efforts and expertise you share with us today. I hope the idea and discussion presented today spark future exploration, collaboration, and innovation in our field. I would also like to acknowledge the organization team, that is the 12th International Conference on Signal Processing and Integrated Network, SPIN2025, and the technical support staff for the seamless coordination, ensuring a smooth and successful session. And I would also extend my thank to Dr. Anil Shukla, sir. Special thank you, sir, for considering me for the session, and a special thank you to Rachit Bansal for coordinating the session. Thank you, sir. Yeah, thank you, sir.
Thank you, madam. Thank you.
Paper presenter, your certificate will be sent to you via the email shortly. And thank you for valuable contributions. I would now like Dr. Shilpa Pawar's permission to close the session. It's been a privilege to have you all today and make this session a success. We thank you, Dr. Shilpa Pawar, once again to take some time out of a valuable schedule and be a part of SPIN 2025.
Thank you, Rachit.
Yes, ma'am. Thank you, everyone, for being a part of SPIN 2025. We will resume with the next session at 2:15. International Signal Processing Networks Conference SPIN 2025. I also wish to extend a warm welcome to all the attending delegates and paper presenters. Everyone, please wait till Dr. Alvaro Rocha joins the session. Thank you.
Thank you so much, Professor Sharma, for joining SPIN 2025 as session chair. Welcome, sir. Welcome, sir.
Good afternoon, Shabi. Am I audible?
Yes, sir, you are. Okay, so do I proceed with the session?
Yes, we can proceed.
So, Dr. Puneet Sharma currently serves as the Dean Academics at SI University, Brangal, and an Associate Dean for the School of Computer Science and Artificial Intelligence. With over 12 years of experience in teaching, research, and administration, he has played a key role in shaping academic excellence. He holds a PhD in Computer Science and Engineering from Amity University, an MTech from SRM University, and a BE from Annamalai University. Additionally, he has undergone Indian Army training at IMA Dehradun, showcasing his discipline and leadership. Dr. Sharma has authored 39 plus research papers in SCIE Index, Elsevier, IEEE, and Scopus listed journals, contributed to Springer book chapters, and holds 2 patents along with the government funded research project. His research interests include cloud computing, cloud forensics, software testing, and AWS cloud education. Beyond research, he is actively involved in faculty development programs, workshops, and international conferences, and has held key positions at Amity University and SRM IST, Delhi NCR. A member of IEEE, he has been recognized by London Journal Press for his contributions to the global research community. With a commitment to education, research, and technological innovations, Dr. Sharma continues to drive advancement in cloud technologies and computing systems. Welcome again, sir. Sir,
Thank
would
you,
you
Shabi.
like
Thank you,
call
Shabi.
upon Anji, sir?
Yeah, we can start. We can start with the paper presentation.
Okay, sure, sir. Okay, now I would like to call upon the paper presenter ID number 85 to present their paper.
Hello, am I audible?
Yes.
Just a sec, I'll share. Is my screen visible?
Yes, it is.
May I start?
Yes.
A very good afternoon to one and all present here. I'm Krishna from Amrita Vishwavidyapeetham, a third-year engineering student pursuing my BTech in the field of electronics and computer engineering, currently in my third year. So, talking about women's health, a very important part of a woman's life is something called menstruation, which comes once they are above the age of puberty. So, what is menstruation? It's basically a biological process where the uterus sheds, leading to hormonal changes affecting mood, emotions, and physical health. Where due to the shedding, there is breaking down, because of which there is blood flow happening through the vagina, which happens every month. And there are immense amount of challenges that the women face during this month. So here we come with our project where we predict the menstrual phases and recommend diet for each phase. Now, importance of a verb. The first question that might come to you is why diet? Why specifically diet? It's because after our study and our study on the present research, we found out that diet plays a very important role in a woman's life, especially during the menstruation. Because having particular edible components during particular phases can actually help them have a more healthy cycle and also lead a more healthy lifestyle. So here is where we give phase-based nutrition optimized energy, metabolism, and hormonal balance. We accurately track cycles enabling tailored nutrition recommendations. address the lack of dietary guidance in menstrual tracking apps, which I just mentioned, helps manage PMS, fatigue, hormonal imbalance through cycle syncing, and provide an intuitive and user-friendly interface for better accessibility and engagement. Now, what is the scope of our project? What exactly are we doing? We are analyzing menstrual cycle data, predicting all the 4 phases, considering regular and irregular cycles, using XGBoost with Smooth for phase prediction, and provide nutrition recommendation via a user-friendly GUI. So now coming to the literature survey part, this is all the papers that we have referred to, which have been closest to our work. And the main paper that we selected was the menstrual cycle data, which is the 2023 paper, which mainly predicts only the ovulation phase. Whereas our project is more novel, where we predict all the phases and also we provide dietary recommendations. Coming to the methodology, has been divided into 3 parts, where comes the pre-processing, model training, and recommendations and predictions. Starting with the pre-processing. So we chose a data set which is menstrual cycle data set, has 1408 instances and 80 features. First, we start with data cleaning and feature selection, where we have removed all the irrelevant attributes, example, the reproductive category. Then excluded features with too many missing values, and we've also handled the missing values and outliers. For example, if there is a menses length above 10 days, we have excluded them. The key features from the data set that we have taken are cycle length, menses length, cycle day, and mean menses score. And then the last period start date. This we have randomly assigned, and it does not influence any of our predictions. Upon the review that we have received from your side, which is the advancement that we made in our project, is the handling of irregular cycles. For handling these cases, we calculated cycle length variation per client, where we calculate the mean and the standard deviation. And we define irregular cycles like for the ones which have deviations greater than 2 SD from the mean. And then we created a separate data set for irregular cycles to improve our accuracy. Then we come to the phase calculation, where for ovulation estimated 14 days before next period, and the fertile window, which is 5-day window, considered for dietary advice. Now, we're aware of the fact that the ovulation phase is only a single day phase. So instead of just predicting the single day phase, what we chose was we took a complete 5-day window where the ovulation can occur in one of these days. As you can see, the histogram has been plotted for the distribution of cycle length and the menses length among users. And then the below graph it illustrates the fluctuation of the cycle length across successive menstrual cycles. This we have picked for a random user. Now moving on to the model training part, which took us the most time to create. So model training first for the irregular cycles is we chose the estimate date or a day of ovulation, that is the predicted day or ovulation day, and length of luteal phase, the days between ovulation and the next period. The model used is XGBoost classifier. Now, XGBoost classifier is a type of machine learning model which works on creating decision trees. How it exactly works is the decision trees which have been created, the trees which are created before, it corrects the errors and it forms it to be a strong tree combined with all of these weak trees and it carries on and multiplies. Then addressing class imbalance. This is a major issue which we had to tackle, and we used a library called SMOTE, synthetic minority oversampling technique. Instead of just creating duplicates, what SMOTE does, it actually creates synthetic minorities, where as seen, it's a synthetic data to balance the phases, particularly the less frequent ovulation phase. And XGBoost handling, it uses parameters like scale, cost, weight to address imbalance. Then hyperparameter optimization. For increasing our accuracy and for optimizing our model, we use the hyperparameter optimization, where we use grid search, that is fine-tuned model for each phase optimizing for ovulation. And then coming to the last part is the dietary recommendation, where personalized advice based on predicted phase and user preference, where there is vegetarian, non-veg, and vegan. Now, an example written here is like follicular phase predicted, and then the food suggested upon the person's preference, that is non-veg, is lentil, zucchini, and turkey. And then also the other diet tips is of course hydration and avoiding refined carbs. Graph, it is each phase and the frequency of each phase, and as you can notice that the ovulation has the least phase even after using hyperparameter optimization. As how the phase works is occurring only one day, because of which the frequency is less. Coming to the last part, which is the in the method, recommendation prediction, as said here, with an example of personalized advice based on the predicted phase. Then we come on to the results and discussions part. So the problem here, XGBoost struggled with minority classes prediction, which reduced our accuracy. So to tackle this, as I said before also, we use SMODE, that balances phases, especially ovulation. And then hyperparametric tuning for further optimization, and soft voting ensemble for XGBoost, RF, SVM, logistic regression, and enhanced robustness. On the right side, as you can see, the comparative analysis, the precision recall F1 score, and average accuracy, there has been a hike in increase after we have applied SMODE and the other parameters. And then below, the impact of SMODE on precision recall, you can see especially for the ovulation phase where it's gone from 0.88 to 0.96 accuracy. And the previous, that is the average accuracy for regular cycles for each phase, is noted. And then coming to the confusion matrix and GI component. Now, another review that from your side, which we have received, that there is no confusion matrix and the quality of the images are low, which also came to our eye, and that's why we worked on it and we improved it. About the confusion matrix, model correctly classifies most menstrual phases. Misclassification was minimal with 100% accuracy for menstrual phase. And about the GUI component, as we use the Python Tinkerlab library, it does not do a lot, because of which we converted this project into a small web development project where we use HTML, CSS, and JavaScript to create this wonderful GUI, where it allows you to input menstrual cycle data, predicts the current phase, and suggests personalized diet recommendation, provides a visual timeline of cycle predictions, significance, and real-world usability for personalized healthcare. In conclusion, I would like to say that this project will play a very important role in a woman's life. Thank you. Thanks for this opportunity, and we are very grateful for all the responses and the reviews that we have given, as it helped us increase the accuracy of our project. And excellent. Thank you.
Krishna, share me your references once.
Yes, sir.
Your references. Wait, make it on the full screen. Make it on a full screen. Make it on a full screen. Make it on full screen.
How exactly, yes, sir? I'm putting on present mode.
Yes. Last, okay. So may I know what was the size of your data set?
So it had total 1400 instances and 80 features.
300 instances and 18 features. So how you have filtered out the raw data?
So basically, sir, our data set had the things we needed, but there are also a lot of extra things like best day for pregnancy and reproductive day, etc. Like the current work which exists, a lot of it just focuses on predicting the particular ovulation phase, because it is the best date for higher chances for pregnancy, because of which this data set had a lot of the extra data. So as I had explained in the data cleaning part, what we did was we removed all of these irrelevant features. Like I said, the reproductive category, and we excluded features which had too many missing values. And also there were some where there were like missing values and outliers, like the menses length, which is like the number of days a woman bleeds. It's generally around like 5 to 6 days, but some of them was above 10 or something like that, which comes in the irregular category. So for a normal this thing, we remove those.
Yeah, right. Thank you.
If anyone else in the audience has any questions, you may kindly unmute yourselves. Okay, so I believe there are not any questions. Before moving on, I'd like to request Mr. Krishna to please show his presenter ID once.
Do you mean my college ID card?
Your presenter ID.
One second.
All right. Sorry to interrupt. Okay.
Yes.
All right. Thank you.
Thank you.
Now I'd like to call upon the presenter from paper ID 167. And before doing so, please show your presenter ID and turn on your camera, please. Thank you.
Hello.
Yes, you're audible.
Yes, just give me a second. I'm getting my ID ready.
All right.
Hello. Am I audible now?
Yes.
Is my ID visible?
Yes, it is.
So can I start
Thank
presenting
you.
now?
Now you may start presenting. Yes.
Okay. So good evening to everyone and all present here. Today I'll be talking about the analysis of Parkinson's disease using machine learning algorithms. So in this, we'll be looking at the introduction, the literature survey, the methodology and the results, and the conclusion and the future works. So starting with the introduction. So what is Parkinson's disease? So Parkinson's. What's your paper ID? Sir, 167. So Parkinson's disease is one of the most common neurological diseases along with Alzheimer's. So it is mainly caused by the lack of dopamine in the brain. And dopamine is not only responsible for mood regulation or motivation as most people think, but it also regulates the body movements. So let's say a person has the lack of dopamine, then his or her body movements are going to be very jerky and stiff and difficult. So this lack of dopamine is mainly caused by the damage to the dopamine producing neurons in the brain. So, as the neurons get damaged, the dopamine levels in the brain automatically reduce, and this leads to several problems which can be seen in Parkinson's disease. And also, along with the motor function decline, we see a decline in the voice of the patients. So, we can see problems like difficulty in speech, monotone, changes in pitch, etc. Sometimes these voice symptoms can appear even before the physical motor function difficulties begin to show. So this is the literature survey. And some of these papers talk about what Parkinson's disease is, how to detect it, what are its common symptoms, while the other papers look at the methods, machine learning methods to detect Parkinson's disease. This can be done either through the spiral images or the voice frequency analysis. So our model combines the spiral images with voice frequency analysis to get a more robust model. So in this way, we are not missing anything. We are not missing the voice, and we are not missing the physical motor decline features also. So we aim to combine both of them to get a more accurate model. And for methodology, we use two different techniques, as I mentioned earlier. One of them is using Archimedean spirals. So an Archimedean spiral is a spiral in which a point moves from another point at a constant angular frequency. So basically we ask the patients to draw the spiral images, and using machine learning algorithms, we analyze their spiral images and see if they have Parkinson's or not. So for dataset collection, the training data is a little bit small, and this is the training data that is used in another paper, another journal paper. It uses 35 images for training and 15 for testing. So since the data set is small, we mainly rely on augmentation here. So we generate about 70 images for training data per image, 70 images per image for training and 20 images per image for testing. So this raises the data set to more than 2,500 images. It almost reaches 2,700 images. And for voice frequency, we took the data from Kaggle. So again, the data set is a little bit small, but we use so in this we took 31 people, out of which 23 are affected with Parkinson's disease, and the rest are healthy. But the total sample size is 195 recordings, which means each person has contributed to more than one sample, more than one voice sample. So this is done to eliminate the basic like inconsistencies or changes in voice depending on the recording equipment or the environment. So at the end, we say that if the person is healthy, the model returns a 0, and if the person is not healthy, then the model returns a 1. For data pre-processing for images, we resized all the images to 128 by 128 pixels. So this is done to like get a consistent size of the images, and then we convert the image to as grayscale, basically a black and white image. So this is done to eliminate like the change in results due to the lighting conditions or the different colors used while making the spirals. And then we normalize the pixel values. So we divided by 255 because like white is 0 and black is 255. So by dividing it by 255, we get a range of 0 to 1. This is for normalization. And for voice samples, we use several techniques like noise reduction, and we extract the useful features like pitch and frequency. So for image, we used 3 different models. One was CNN, Ada Boost, and Random Forest. And for voice samples, we used KNN, Random Forest, and SVM. So we used like these parameters to determine the overall performance of a model. And as for the results, we had the best result with CNN. Random Forest and Ada Boost had slightly lower accuracy of 76%, while CNN reached almost 90, but it's 89.84%. So the reason for this is CNN is able to extract spatial features like curves, distortions, and noise from the images, while the other models rely on may not be able to analyze the images that well. And we also used max pooling, multiple convolutional layers, and small learning rate. And these images show the model accuracy and model loss. So coming to the confusion matrix, it detected 270 subjects as healthy, and they were healthy. So in other words, it's true positive value. And it successfully detected around 296 individuals with Parkinson's disease. So there is a small misclassification of 45 subjects and 19 subjects respectively. And for voice frequency analysis, we got a notable accuracy of 94% with Random Forest, while Canon and SVM were very close behind at 91 and 88 percentages. And since most of the patients had Parkinson's, it was able to detect most of the people accurately with a very small misclassification of 2 people who were healthy, but they were detected as Parkinson's. So, as we can see here, this is a spiral drawn by a healthy person, and at the bottom we have the voice frequency analysis, which shows various parameters of the voice. So it gives a confidence score of 99.76%, meaning that there is a 99.76% chance that the person is healthy. So at the end, we can see a small 0, which tells that the person is healthy. And this is the analysis of a person who definitely has Parkinson's disease. And these are the previous works based on which we created our paper, or we took some ideas from these papers. So this for image analysis and this for voice analysis. So looking at all of this, it is clear that the machine learning algorithms are very effective for detecting Parkinson's disease. And the combination of images and voice provides a more robust model. In place of using a single model, you can combine both of these into a stronger and better model. So in this way, we're not missing the motor functions of the patients, and we're also not missing the voice. And as for the future enhancements, I think the dataset that we used was small, and we mostly relied on augmentation. So I think to make it better, we can use more varied dataset with more people and more drawings. And we can also integrate more parameters like handwriting analysis, eye movements, and memory problems, for example. And at the end, we can also create an app which can provide an easier way for the patients to check their own health without actually relying on expensive machinery like MRI scans or PET scans. And thank you.
Okay, Sainik, you have used your data set. So how much percentage you have used for your training and testing parameters?
Sir, we used 35 images for training and 15 images for testing.
But only 35 images?
Yes, sir. We mostly relied on augmentation.
That data set, the trainings and testing parameters are very less. Okay, which filtration technique you have used?
Sorry, for the images?
Filtration technique.
Like for the images?
Yes.
For the images, we used max pooling, and we converted them to grayscale.
Why only to grayscale?
Sir, because let's say a patient is drawing an image, they can use a different colored ink like blue or red, and the lighting conditions might be different. So to avoid all these problems, we maintain a consistent input with black and white images.
So how many algorithms you have compared for reaching out to this using this algorithm?
Sorry, sir. Can you please repeat?
how many existing algorithms you have compared with your proposed algorithm?
How many? Like we compared it against decision trees, SVMs. And
so what were the drawbacks which were not overcome in your algorithm?
Our algorithm.
Your what algorithm you have used? So how it overcome?
So firstly, there was an increase in accuracy given because CNN is a vision-based algorithm, so it was able to extract the visual features from images more effectively compared to the other models.
Thank you.
Thank you, sir.
If anyone from the audience has any questions, you may kindly unmute yourselves. I believe the audience does not have any questions. Moving on. Moving on, I would like to call upon presenter ID 172, Lakshmi Shaw. And before starting, please show your presenter ID. Thank you.
Thank you, Chavi. Am I audible?
Yes, you are.
Okay, let me share my screen. Okay, my video is on.
Yes.
Yeah. Okay, this is my ID. I hope it is audible.
All right. Can you bring it closer to the camera, please? Thank you.
Or else, at last I'll show again. Okay. So, good afternoon, everyone. My name is Dr. Lakshmi Shaw, and I'm excited to present our research title, Isolation Forest-Based Anomaly Detection for COVID-19 PCR Testing. So this work is in collaboration with my co-author, Professor Tahir Akin at Texas State University. In this presentation, I will discuss how we leverage machine learning techniques, specifically isolation forest and TSNE, to detect anomalies in COVID-19 PCR test data. So let's begin. The COVID-19 pandemic created a need for extensive testing to monitor and control the virus spread. PCR testing has been the gold standard for detecting infections, but with such a massive volume of data collected over time, anomalies can arise due to errors, inconsistencies, or emerging trends. Detecting such anomalies is crucial because unreliable data can mislead public health policies and responses. To address this, we propose integrating isolation forest for anomaly detection with TSNE for data visualization. This combination enables both efficient detection and better interpretability of anomalies in the dataset. So, traditional anomaly detection methods such as G scores, control charts often struggle with high dimensional healthcare data. Machine learning has emerged as a powerful alternative with models like one class SVM and autoencoders being commonly used. Isolation forest is a tree based ensemble method that efficiently isolates anomalies by recursively partitioning data. It has been widely used in fraud detection, cybersecurity, and healthcare analytics. On the other hand, TSNE is a dimensionality reduction technique commonly used to visualize high dimensional data. So here TSNE is basically T distribution stochastic never embedding model. So it helps us see hidden patterns in complex data sets. While both methods have been applied separately in various domains, integrating them for anomaly detection in COVID-19 PCR test data is relatively unexplored. So, which is the motivations behind our study? Now, let's dive into the core methodology of our study. We use isolation forest, which works by constructing multiple decision trees and isolating outliers in fewer splits. Since anomalies tend to be far from the majority of data points, they are isolated quickly. So we also use TSNE, which maps high dimensional data into a lower dimensional space while preserving relationship among data points. This helps us visualize normal and anomalous data clusters more effectively. The key idea behind our approach is first applying TSNE to reduce dimensionality and then running isolation forest on this transformed dataset. So this enhances both detection accuracy and interpretations. So our dataset consists of COVID-19 PCR test results collected from over 1,000 testing locations across US. The data spans from January 2020 to January 2024 and includes attributes such as state, FEMA reasons, test outcomes. So, pre processing is a crucial step in anomaly detections. So, we handled missing values, normalized numerical features, and performed basic outliers filtering to improve data quality. So, this prepared dataset is then used for training our isolation forest model. Okay, coming to this figures represents the number of COVID-19 PCR test results reported over time. We observed significant peaks in late 2020 and early 2022, corresponding to COVID-19 waves, including the Omicron surge. After early 2022, we see a decline in testing, which stabilized by mid 2023. This suggests improved vaccination rates, reduced infections, or a shift in testing policies. To better understand these trends, we applied change point detections, which helps identify key transition in the datasets. So figure 2 shows the change point detections and certain patterns in the dataset. Now let's look at how our model performed in detecting anomalies. This TSNE visualization show how similar data points are grouped together. The color-coded data points represents their anomaly scores as detected by the isolation forest models. In our analysis, 5% of the data points were flagged as anomaly, meaning they exhibited unusual test reporting behavior. So we evaluated the model using standard performance metrics and found an accuracy in the sense of area under the curve and receiver operating characteristics of 1, with precision recalls and F1 score also reaching 1. While these perfect scores indicate strong model performance, they could also suggest overfitting, which we address in the discussion. Okay, so this table presents a comparative analysis between our proposed isolation forest with TSNE model and existing anomaly detection techniques used in similar context. So let's discuss our proposed method first. So in the isolation forest with TSNE applied to COVID-19 PCR test data, achieved a perfect score like precision recall F1 score of 1. This indicates that our model can detect anomalies flawlessly, and but there is a risk of overfitting, which we will address in future work. Now let's compare with other studies. So one of the studies in Uni used an LSTM autoencoder for COVID-19 time series data. They reported high performance but did not provide an area under the curve or receiver operating characteristics score. So next is our another study people have done like Navas. So they have applied an autoencoder ensembles model on biomedical data, achieving an area under the curve and ROC of 0.92 with strong precision and recall. However, autoencoders tend to be computationally expensive. Then another piece of work that is Liu et al. They have employed one class SBM for industrial fault detections. I mean, as an anomaly, achieving a high area under the curve and ROC of 0.95, showing that SVM is effective in structured anomaly detection. Apart from that, one another piece of work which is published in 2024 used local outlier factor for medical data anomalies, obtaining a AUC ROC of 0.9, and local outlier factor is known for handling density based anomaly in this case. So the key takeaways in this comparative table is our method surpasses existing technique in performance, but given the perfect score, we must validate its generalizability further. And apart from that, autoencoders and SVMs are effective alternatively, though they come with computational cost or require structured data. So, in conclusion, our approach demonstrates high anomaly detection capability, but it needs further validation to ensure real world applicability. So, the anomaly detected in our study could be attributed to various factors, including data entry errors, inconsistent test administration, or even emerging variants affecting test results. So, one key takeaway is that while machine learning models like isolation forest are highly effective, expert validation is essential to ensure meaningful interpretations. To improve future implementation, we suggest parameter tuning, testing other anomaly detection model, and integrating real-time anomaly detection for immediate public health responses.
Right, I have a question for you, sir. The question is that what are the challenges you have faced while developing your model?
For isolation forest,
Yes.
yeah, as I mentioned in the presentation, first thing is that the preparation of the data. The data is not structured, first of all, and it comparison, I mean, it's an heterogeneous data mixed of both numeric and categorical data. There are lots of gaps in the data also. So, cleaning of the data set or preparing the data set before fitting into the isolation forest model is the challenging one.
What process you have used for cleaning?
As I mentioned, that the first pre-processing technique we have used as a cleaning of the data or removing the missing values with their mean.
What algorithm or what process you have used? That's okay. Cleaning of the data is okay, but what is the method name or what is the process name?
Yeah. So in our data set, we have couple of gaps as in zeros or null values. We fill them with the averaging method in the numeric of values. And in case of the categorical data, like regions and other things, we kept it as it is. So this is one of the method we have used. Apart from that, we have removed some of the unwanted features like attributes FEMA regions. Those are not required for the isolation forest model training. So these are the two pre-processing technique or cleaning method we have used in our COVID-19 PCR data.
Thank you.
I hope am I clear in this sense?
Thank you.
Okay. Okay. To summarize, we successfully applied isolation forest and TSNE to detect anomalies in COVID-19 PCR dataset. Our approach achieved high anomaly detection accuracy and provided useful visualization for interpretations. So future work will focus on enhancing model robustness, integrating real-time monitoring system, and analyzing COVID-19 testing patterns across different regions and demographics. So these are the couple of references, significant references which we have used for comparison of our work. So that concludes my presentation. Thank you for your time, and I would be happy to take any questions if you have.
Okay, so I believe there are no questions from the audience. Moving on, I'd like to call the presenter from paper ID 155, Rohit Rai. And before doing so, please show us your presenter ID, sir. Thank you.
Yeah. Hello. Hello.
Can you zoom that in a bit?
Works?
Hanji, thank you.
So, good morning, everyone. This is my team, me, Ajit, and Sarthak, and we are presenting the paper XAI models for more mortgage approvals. So, let's start with introduction. Good morning, everyone. My name is Rohit Rai, and today I am thrilled to present our research on loan acceptance prediction using explainable AI. As we are seeing the AI boom, in the same way we can see that AI-driven systems are transforming banking and loan approvals too. But key challenge remains opacity. Applicants often don't know why their loans are approved or rejected, leading to distrust. And hence, we are trying to solve this problem with our research. So, if now I talk about my problem statement, so loan approval processes are traditionally opaque. AI models like deep neural networks are good, but they have some problem called black boxes, which means humans are not able to understand how they are processing uh, any data inside them. And that's why we needed a simple approach which uses basic machine learning modeling, and even it can integrate an explainable AI with it to give a optimum output. And hence our solution leverages XAI techniques to bridge this gap, ensuring that decisions are accurate, interpretable, and fair. So, sorry. So, talking about my methodology, the methodology that we followed, the yeah, sorry. Yeah. So the methodology we followed is that firstly let's discuss about dataset. So there we got some default loan defaulted dataset on Kaggle, and some of the data we tried to augment it. Not augment, we tried to scrape it from various sources. Now we had 45,000 rows of data and 37 parameters. So now as we have lots of data, so there were many issues in the data, and hence we used data binning by mean to remove excessive null values, and even we used one hot encoding for encoding our categorical variables. Now the thing was, we made an heat map to understand key what is the relation of parameters to an output, and hence we found ki bahut sare we found ki there are many parameters which are very much related to which are very much related to output, but we needed one very strong parameter, and hence we did feature engineering and we got debt to income ratio, which was very much related to output. Now once we are done with the data, then we shifted to model. Now, model selection was our major concern. So, what we did, rather than selecting model, we tried using every model: random forest, SVM, gradient boosting, and XGBoost. But we saw we achieved the highest accuracy of 94.4%, 94.47% accuracy in XGBoost uh, because of second order gradient derivation with tree pruning. The major the advantage that we saw in XGBoost and why we choose XGBoost was the tree pruning. It doesn't deeps down the useless branches, and hence we used XGBoost. And even XGBoost used multiple cores of CPU to train the model and give output, and hence we saw it as an better and better than other models, and hence we used it. Now the question arises, we use this model, but where are we using uh, XAI? So in XAI there are three powerful XAI tools. One is shapely additive explanations. So what is it? It provides the global feature importance. For example, credit score contributes 30% to the decision, something like that. Then second tool that we used was Lime, local interpretable model agnostic explanation. So ये क्या करता है? Basically it does instance level explanation. It will be like, if my loan was rejected, it will say your loan was rejected due to a high DTI ratio. And hence now if I talk about, yeah, there is one more thing that we have done to test. So basically agar if we get ki you are not eligible for the loan. Now what we do plus 50 and minus 50 on the parameter to understand ki agar 7, if his score was 500, and if it is rejected, so we will test it for 550 and 450, and we will tell him if your score would have been 550, then there was this percent of chance to there was this percent of chance of approval of loan. So, and this is our XAI approach. Now there was one issue that we faced was imbalance in data. As the data was scraped and took by Kaggle, so there was a issue keep thoda positive data and there was little bit of negative data, and hence we tried using stratified sampling so that we get balance of data on the both sides. So now let's move to, yeah, I have discussed these points. Now let's move to these results and discussion. So if we see in result and discussion, we saw that key predictors that we have are credit score, down payment, and repayment history. Now we also, as I said, we are doing plus 50 and minus 50 to get to predict what user can do better for getting approval of loan. Hence Lime helped in this too much. As you can see, Lime, we provided recommendations like to improve your loan chance and increase your credit score by 50 points. So like something like this. Now if we see the impact of our solution is that applicant and lender, both of them gets clarity, so that like there won't be distrust. Everything is trustful. And if I talk about, we all we also gave user what they can do to get better score and get loans easily, which took help of, like, this is what I discussed before. Now if I talk about see, this is the graph that we created. This shows the relation how when I will explain you. In XGBoost there was one parameter, pause weight, scale pause weight. We tuned it, and we and that after tuning it, we got these graphs to show how the amount of the down payment is related, how much down payment is relational to the application, then for approval and rejection in such way. And then there was one more thing, depending on the credit, we were trying to get a relation between credit and down payment. So these are the sharp analysis that we got for whole dataset, for global dataset that I discussed before. Now, if I talk about conclusion, so our counterfactual explanation is helpful for too much for lender and borrower both, and hence we got a better model. Now, in which sense I'm saying better model? So so these are two research papers that we deep dived into. The first one was just using SHAP and was getting the accuracy of 85 or 86%. It wasn't having that good accuracy, and hence we tuned some parameter, as I said, scale pause weight, scale pause epoch, and hence we got a better accuracy in comparison to them. And the second one was just helpful to understand how the prediction model works in banking system, and hence because of that we were able to comply with some ethical concerns. Yeah, thank you. I'm done with the presentation. If anyone has some questions, so hello.
Yes,
Yeah.
thank.
So for my side, there is no question for you.
All right. So if anyone from the audience has any questions, please kindly unmute yourselves. I believe the audience does not have any questions. Moving further, now I'd like to call upon presenter ID 224 to present their paper. And before doing so, please show us your presenter ID.
Okay. So thank you for inviting me. So yeah, I'm going to share my screen. I'm audible. Hello. Hello. I'm audible.
Yes, you are audible.
Okay. 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 Let me share my screen. So my ID is visible.
Yes, it is visible. Thank you.
Okay. My presentation is visible.
Yes, it's visible.
Okay. So can I start my presentation? It's visible, right? Hello.
No, your screen is not visible.
Okay. Just a minute. Now it's visible.
Yes, now it is.
Okay. Okay. So Chavi, excuse me for a minute. Chavi, can you give me a call, audio call on my number?
Sorry.
Chavi, can you give me a call on my mobile?
Oh, all right, sure.
Right. Thank you. You can continue. Okay, sir. So, good afternoon, everyone. My name is Kamal. I am a research scholar at IIT Guwahati. So, I am doing my PhD in School of Data Science and Artificial Intelligence. So, my paper ID is 224. Today, I am going to my research work on lightweight handnet, a dynamic hand landmark detection model for real-time applications. So, these are my authors. So this is my outline. So first I'll go through the introduction, then challenges, contribution, proposed model, dataset, experiments, results, and then finally conclude this. Okay. So comes to the introduction, like why hand gestures are important. So basically hand landmark detecting and tracking is very important in various research fields such as like human computer interaction, augmented reality, hand function rehabilitation, like by using landmark detection we can make rehabilitation exercises so that user can perform using their home, like in their home only. And next application is sign language recognition. They can use this technique in the sign language also. So what was the problem? So basically traditional methods for hand key point detections are computationally intensive, limiting their applicability in real-time systems. So this is just overview of hand key points. So basically there are 21 hand key points, and each key points has their unique name and unique ID. So basically hand landmark detection involve localizing key points on the human hand and finding 21 hand key points corresponding to joints and fingertips. So this is process that how we can find the hand key points. So basically the hand landmarks detection models identifies specific key points on the hand such as finger joints and fingertips. Suppose let's suppose we have an input image I of an hand. Our task is to predict a set of 21 hand key points or landmarks. Those have coordinates xy coordinates. Suppose for the 2D key points, let's we have xy coordinates for particular key points. Okay, let's suppose this is particular key points and it has two value, one value corresponding to x and one value corresponding to y. That is the coordinates. So suppose we have x1, y1, x2, y2 till x21 and y21. These are the coordinates we have for each key points. Okay. Now these are some challenges in traditional methods like computational complexity. So many high performing models use a deep learning and complex architecture that requires significant computational resources. So that might not be like useful in edge devices. And next challenge is real-time inference requirements. So this is very important in many applications such as sign language, augmented reality, virtual reality, and human computer interaction. And next one is robustness across variation. This is also like very important role. So basically a model should generalize across variations in the hand size, hand pose, rotations, and occlusions. Now this is my contribution. So basically we design a lightweight model by using mobilenet v2 as a backbone for extracting the features. Then after that we pass those features in the custom based CNN regression head for getting the key points. Okay, then we have trained and validated our model on freehand and CMU hand dataset. And our model is also has like a high FPS, so it can be work in real time inference on edge devices. So this is our proposed model. So first first suppose we are passing the input, then we are resizing the input into 224 cross 224s with 3 channels, red, green and blue, and then we are linearizing it for the model. Then finally we are using mobile net model for getting the features. Then finally we are getting the features 1280 cross 7 cross 7. Then after that we are passing these features into the custom based regression head. Then finally after applying the convolution layer, average pooling and flatten, then finally we are getting the 21 hand key points. Like in flatten we are getting 42. Basically 42 means basically 2 coordinates for each key points. Then finally we are getting 21 key points, and here we can see that we are visualizing the key points on the actual image. Now data comes to the data set. So basically we have used CMU hand data set and free hand data set to train, test and validate our model. CMU hand data set basically it contains total 2758 annotations with the 1912 for training and 846 for testing. And it is collection of high resolution and diverse hand pose images and key points annotations for each hand. Now comes to the free hand data set. Basically it contains 32,560 unique training samples and 3,960 unique evaluation samples. And also it provide both 2D and 3D annotations for the hand key points along with the ground truth, hand mask and segmentation map. And comes to the data pre-processing. So we apply some pre-processing before passing to the model, like resizing the image into 224 cross 224 pixel and normalizing in the range of 0 to 1 using minimax scaling. Then after that we are applying some data augmentation to make the larger data set size. So we apply some data augmentation like random rotation. We apply random rotation within range of minus 30 degree to 30 degree. And then after that we apply scaling and translation. So we selected a scaling factor within range of 0.8 to 1.2. And then we applied the Gaussian noise also. So we added Gaussian noise with a mean of 0 and standard deviation of 0.01. Then we apply the horizontal flip also to learn the better features. Like we apply horizontal flip with the probability of 0.5. Now comes to the experiments. So this is a training process. So for model training we use PyTorch with Kaggle's T4 GPU. We divided the data set into training, testing and validation sets with the ratio of 70%, 15% and 15% respectively. And comes to the loss function. So basically we use mean squared loss functions. Here is the mean squared loss functions formula. Like first one is 1 by n is the number of images, and m is the number of like key points, and then Kij hat is the predicted key points and Kij is the actual key points. Then we are getting calculating the mean squared error on those. Now these are some hyperparameters that I use. So these are for learning. Basically learning rate, we use initial learning rate as 10 to the power minus 4 with a decay rate of 0.1 after every 10 epochs. Then we use batch size of 32 and epoch. We run on 150 epoch. Then we use the weight decay also 10 to the power minus 5. And for the evaluation we use some evaluation metrics for the performance evaluation. We use mean squared error, mean absolute error, percentage of correct key points and inference speed also. So this is the comparison with the state of art models on the freehand data set. So first paper was they use ResNet 50, then they got AUC as 86.5 and 5%, and MSE as 4.2 mm, and PCK on threshold of 0.2 they got 87.2, and parameters was 34 million, and G flops was 7.29, and inference speed was 180 millisecond. And next paper was 89.2% AUC and 3.2 MSC, and 98.7 was PCK on 0.2 threshold, and similarly other methods. In our model, we got AUC as 98.5% and MSC on 0.81, and PCK on 0.2 threshold we got 99.2% PCK, and parameters was 2.6, and G flops like little bit higher compared to LGCA net. So it was 2.56 G flops, and inference speed was lower than all of the other models, like 13.48 millisecond. So these are the curves, loss curves. So basically here we can see our loss is minimizing over the time, but after 130 epochs it was not like it was not decreasing that much. So we trained till 150 epochs only, and comes to the MPJPE curve. So mean per joint per error is this is the curve. So we can see this is also minimizing over the error over the epochs. Okay. So these are the qualitative results that we can see. That qualitative result shows ground truth as green and predicted key points as blue on sample frame with various hand poses and lighting conditions. So here we can see that our model is predicting like similar to ground truth only. Like in some cases it's not predicting, but in like almost in every case it's predicting like similar to ground truth only. Now comes to the conclusion. So basically we developed a lightweight hand key point detection model for real-time applications, and we utilize MobileNet v2 as backbone for feature extraction, and along with the custom based CNN regression head for hand key point detection. And we train and tested our model on CMU hand and freehand dataset, and achieving an overall area under the curve is 98.5% and PCK on 99.20% on the freehand dataset. And in future work, we aim to extend our model to support a wider range of key points, improve dataset generalization, and explore applications in like virtual reality and augmented reality, sign language recognition, and robotics also. So these are reviewers comment. So this is the first reviewer comment. So it was like positive only, and like paper is well written and all these things. And this is a review from the second reviewer. This is also a positive comment only. So yeah, based on there some suggestions, that based on that I have prepared my final camera ready paper and I am submitted. Thank you. And these are some references that I used in these slides to prepare my slides. Thank you. If you
can you come to your methodology part?
Yes, sir.
Yes, that's okay. That proposed methodology will be a diagram.
Okay, sir.
So in this, you were telling about the input signals, what you were taking about.
Input
so
image,
what will be
yes.
the for input image and output image? So what will be the drawbacks when you are taking an image? What type of lags it's coming when you capture an image? Did you experience that lag?
Sir, actually, I converted these images into the tensors. Then I am passing those tensors into the model.
Okay. So
yes.
It's okay, but when you are capturing some images, some lags will be there. So
sir,
how you are
sir, these
those
are
lags?
Okay, sir. Sir, these are not real-time images. These are from the data set. Yes, sir. These are from the data set, like the from the freehand data set. So I took
you
these
have
images
you
from
have
the
downloaded the
dataset.
data from the online websites.
Yes, from the publicly available dataset that I already told. I used two dataset for the generalization. One is CMU hand dataset, and next one is freehand dataset. So this image from the CMU hand dataset.
Right, right.
Yes, sir.
Okay. So when you have downloaded dataset, there will be some garbage data. Which technique you have used to clean that dataset?
Okay, sir. Actually, dataset is not garbage. They basically already annotated the data, and they prepared all the annotations for the key points. Then we pass those key
But
points.
filtration would be required.
Yes. For the pre-processing part, we use some resizing and some cleaning part to do all these things.
Nice work. Good. Thank you.
Thank you so much, sir.
Okay, so thank you. Due to time constraints, we'll move forward. And I'd like to call upon the next speaker, paper ID 1, to please present their paper. And before that, please show us your ID.
Good afternoon, ma'am.
Good afternoon.
Yes, my screen is visible.
Yes, it is.
Yeah, this is my ID.
Your ID is not visible.
No?
No. Yes, it's visible now.
Okay, ma'am. Thank you. So I will start with presentation. Yeah. Yes. Yeah, good afternoon, everyone presenting over here. My today's topic is AI-based air quality tracking for smart city management. So here, especially what I have done is like for this study, we have focused four main Indian cities for the air quality: Delhi and Kanpur and Lucknow and Jalandhar. These cities were yeah. The- yeah. These cities were chosen due to their varying level of pollution and different climatic conditions, allowing us to assess how many machine learning models performing across diverse urban environments. So I have used a data set from the Kaggle, especially meteorological data and air quality data. By combining these data sets, I aim to develop a robust predictive model that can help urban planners to and policy making where make informed decision for improving air quality in smart cities. Coming to the introduction, uh, I have been referring to the references that rapid urbanization layer, which has resulted in evaluated toxic levels and clear indicators of climate change, where with the 1.3 million residents, we can see that Delhi was most populated state in India in 2022 and estimated population of 1.4 billion, and Delhi's highest population density makes every district in an urban area. Coming to the literature review, I have reviewed some of the references here, where in first reference, I have seen that strong short term retention graded recurrent units, and another one where they have inputted that temperature, humidity, air quality index, additional environmental, and which has resulted that optimal levels of temperature and air quality for the health. The main limitation what they mentioned is like additional models have to be used for the hybrid approaches especially. And for this research, the main objective is like the primary goal of this research is to develop an accurate and efficient air quality prediction model for smart cities. So my objectives here including is like applying machine learning and deep learning techniques to forecast air pollution levels and understanding the relation between meteorological factors and air pollutants and optimizing feature selection to improve and prediction accuracy and model level interpretability and identifying the key variables that impact air quality the most, helping like policy making focusing on essential environmental as well. And this is a proposal methodology where I have used a data set from the Kaggle, and this is the data set description and meteorological observation and makers of air pollution as well. And this is the graph that plotting of contaminants and meteorological information distribution at especially in Delhi region for the air monitoring station. And this is the denizen information like where the number of people the especially graph shows that concentration levels especially in the cities, and this is the like how the industrialization and urbanization and what is the population density is increasing the air quality especially. And this is the data processing, and this is the proposal methodology where I have used a data set and this is pre-processing, and I have split training and testing by 70-30%, and I have and this is the and use it for model performance analysis and the optimization techniques as well. Coming to the results and discussion, we can see that like I have used sorry, we can see that the comparison like where ADA boosting and random forest MLP SPR and K range saber and long short term memory, the comparison models as well. Coming to the results and discussion is like it introduces the several key improvements like over traditional air quality prediction models, like using of these deep learning models like long short term memory to capture long term dependency in air pollution trends, and implementation of feature optimization techniques to remove redundant data and enhance prediction accuracy, and as well as comparative analysis of multi machine learning models. As I said now, yes, we support vector machine, random forest, and Adabus and K-range neighbor with the deep learning methods like MLP and LSTM, and to identify the effective approach, and especially the application of the model across multiple cities to improve generalizability and adaptability for different urban environments as well. Coming to the conclusion, to improve the generalization, this study could improve the by adding data from more states actually, where I have used 4 to 5 states. So one problem that came to light was incomplete data collection, that was real-time data analysis, like where I have used it from the data set from the resources. So the future research should be combining edge computing and IoT systems with prediction models for air quality, and digital twinning could be used to track and anticipate patients level, especially in health assessments. And these are the references where I have to. Thank you.
Come to you, Jara, once your implementation part, that is slide number 6.
Yes, sir.
Make it full screen. So how you are capturing this air pollutants data? From where you have taken this data?
Sir, I have taken this data from Kaggle, sir, actually.
What was the size of data set?
The size of data set is like around it is like features of it containing.
Not aware of it.
No, sir, it is containing like some of the features where, and it is containing of 10,000 columns as well, sir.
Okay, so how you have filtered the data set?
So by filtering the data set, like we'll see that especially what is the percentage of the cities are containing like that, sir. I will filter the data, especially of the 4 cities.
What's your accuracy rate of your data? Output, sorry.
Yes, sir. Sir, 85%, sir.
It is okay, feasible, good.
Yes, sir. That's what I have especially mentioned in conclusion, that even for the future research, I need to improve the accuracy, and as well as I have to use the real time sources as well, sir, to improve the accuracy for the systems with prediction models for air quality, sir.
Thank you.
Thank you, sir. Thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves. I believe the audience does not have any questions. Finally, that was the final paper. I would like to thank each presenter who presented their hard work, and it was a really fruitful experience. I would now request Dr. Anil Kumar Shukla to present for Dr. Puneet Sharma a certificate as a token of appreciation for being our session chair. Thank you so much, sir. Your presence really lifted the entire session's experience.
Thank you, Chavi.
Thank you so much. Thank you so much, Dr. Puneet, once again for joining SPIN 2025.
Thank you, sir. Thank you so much for giving your valuable words.
Okay, so paper presenters, your certificates will be sent to you via email shortly. Thank you for your valuable contributions. I would now like Dr. Puneet Sharma permission to close the session. It's been a privilege to have you all today and make this session a success. We thank you, Dr. Puneet Sharma, once again to take some time out of your valuable schedule and be a part of SPIN 2025. Thank you all for being a part of SPIN 2025. We'll resume with the next session at 4:30.
Thank you. So I'm leaving. Thank you.
Uh, Very good evening to one and all. I, Rachit Bansal, on behalf of the Departments of Electronics and Communication Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, feel honored to welcome you all to the first day of the 12th International Signal Processing and Integrated Networks Conference in 2025. I also wish to extend a warm welcome to all the delegates and paper presenters present here. It's a great privilege to have Dr. Carlos M.T. Gonzalez with us today. I would like to invite Dr. Anil Kumar Shukla to present a sapling to Dr. Carlos M.T. Gonzalez.
Thank you so much for your presentation.
So much, sir, for joining SPIN2025. Thank you so much.
Thank you to you, Dr. Anil. Thank you so much. Okay, I can start my presentation.
Sir, would you like me to give your biography once? Then you can begin.
Sorry.
Okay. Thank you. Dr. Travieso Gonzalez is a full professor and head of the Signals and Communications Department at the University of Las Palmas de Gran Canaria, Spain. With a career spanning over 2 decades, he has been actively engaged in teaching and research since 2001, specializing in pattern recognition, learning theory, and medical signal processing. His contributions to the field are extensive, with involvement in over 50 international and national research projects, many as the principal investigator. He has authored over 480 research papers, co-authored 4 books, co-edited 25 proceedings, contributed to 24 book chapters, and holds 7 patents. His expertise has also led him to supervise 12 completed PhD theses, with 7 more currently under supervision, along with mentoring over 150 master students. Beyond research, Dr. Travieso Gonzalez is a key figure in global academia, founding and presiding over major international conferences like IEEE, IWOBI, IPPIS, and InnoEducatic. He has served as general chair for multiple prestigious conferences, further solidifying his influence in the scientific community. His expertise is sought after by top research funding bodies, serving as an evaluator for the EU Horizon Europe, Medical Research Council in the UK, and national agencies in Spain, France, Germany, Argentina, and Colombia. A dedicated academic, researcher, and innovator, Dr. Travieso Gonzalez continues to shape the future of artificial intelligence, biomedical engineering, and intelligent systems. Welcome once again, sir. We are honored to have you grace at SPIN 2025.
Thank you so
And now
much
I would request, Anji. Yes, sir. Now you may begin with your topic on your presentation on the topic effective computing for Alzheimer's, unlocking the power of visual data.
Okay, thank you so much for your introduction for the presentation of my talk. Okay, the idea is to show to you my research work about the medical with medical doctors. In particular, today I would like to show to you the one presentation about with the title is effective computing for Alzheimer's, unlocking for the power of visual data. Oh. Oh, sorry.
Yes, so now it's visible.
Okay, thank you. Okay, the presentation have different points. Little we can see introduction. After this, presentation versus emotional state is a very important point, in particular for neurological disease. Our general idea. After this, I would like to show to you 2 different approaches. One of them is expression detection from facial images, and the second one is emotional state from facial images. We can say later the difference between us. Later we can see the interface that we can have, and finally conclusions, future lines, and acknowledgement. Okay, about the introduction, nowadays is possible to work because the different advances that we can have with artificial intelligence, we can have now a very powerful computation with different kind of devices, sensors. All this technology is well known for the world, and for the reason we can have now a better collaboration with medical doctor. Working with medical doctors sometimes is very difficult, but all this new technology that we can have, this Industry 4.0, is key in order to start to work or start to develop different kind of tools, in this case for medical applications. Here in this work, the idea is to research about the emotional state. Okay. It's key in order to know what is the state of for different neurological disease in human is only because one symptom that this the elder have is that lost the motion, lost the different or lost the expression in the face, and the idea is to try to detect this kind of issues, in particular for Alzheimer's disease. Now we have different kind of sensors. In this case, we can use a camera. The idea is to try to quantify this information. Okay. This work is a collaboration that we can have with Brno University of Technological, in particular the hospital in Brno in Czech Republic. With this information, with these different videos that we can have, it's possible to develop this research. About the expression detection and emotional state, we can have two different ways to work. The first thing is to know that we can have in the FACS, Facial Action Coding System, we have typically we have 8 different emotional expression. Anger, the good, fear, happiness, sadness, surprise, neutral, and content. The idea is to try to detect the emotion that have the different persons, but in the case for the person with Alzheimer, it's so much important to neutral expression, because this kind of person lost expression is a typical symptom in neurological disease, because the brain is not working well. For the reason lost to give this order to the body, in this case the face, in order to show this expression. For the reason it's very interesting to detect the neutral expression. And the idea is to try to quantify the grade of this neutral expression. Okay. For this one, we can have 2 different kind of options. We can work with expression detection, with different kind of expression, or we can try to detect the grade of the emotional state. Here, we can put all the emotion in this graphic. It's the typical in psychology. In this case, in order to know the grade of the expression, the idea is to detect the level of the arousal. Okay, we can see here the arousal is when you have so much low level when you show your expression, independent of the expression, or you have a very high level of this expression. The idea is to try to detect this. Or the other way is to try to detect the different kind of expression that we can have. Working with neurologists, said me that it's very important the movement of the mouth. Okay, the speed that the person have when speak, and we try to detect this speed of when the people is speaking, and to try to detect the different movement of the mouth is very important. And this work is this is the motivation in order to try to quantify this information, because now this information is literally the medical doctor, we can see this kind of symptom, and the idea is to try to quantify this. For the reason, we propose a general idea in order to work. Okay, we can have a multimodal data set. Okay, here in our data set we can have sound, video, writings, physiological signals. We can have many kind of information. This is the idea. We are working nowadays with video, but we develop another approach working with sound, with the voice, in order to detect this information with the voice. But now I would like to show to you this part, okay, the use of the video in order to detect this emotional state. In the future, we would like to work with another kind of modalities, okay? And finally, the idea is to have a multimodal data set. Okay? In order to use this video, we can have the first approach, is the expression detection. Okay, we can have here the general DRM block. It's a supervised system where the idea is to try to extract information from the face for the reason we can detect the face, and to try to extract information before to have automatic classification. Okay, for the processing, we can see that we apply 4 different steps. The extraction of the facial area, the use of the breadness, filtering of the image, and finally we can have the binarization, the information of the face. Okay, here we can see the image. The first step was to use a public data set in order to start to develop our approach. We can try to use the different breadness that we can have in the image in order to enhance the information. After to apply a high pass filter, we can apply the binarization approach. Okay, we can have this information. This information, the idea is to have this information in order to detect the main part of the face. Why? Because the idea is to try to detect where we can have the information when we show the expression. Okay, for the reason we split the image in different parts. Okay, the segmentation of the forehead, the both eyes, the isolate eyes, the different part of cheek, the mouth. Okay, and of this way we can propose different kind of part of the image. We can have all the segments, is TP, or we can use the eyes together with the mouth. We can use the both eyes with the mouth, only the eyes. We can use the forehead, or we can use only the right eye or the red eyes. Okay. This is the information that we can have for the previous one from the binarization image, and the idea is to compose different kind of part of the face in order to detect where we can have information. Okay, another way is to use different kind of distance in the face, because when we can have a different expression, change our face. Okay, and to use a transform domain for images in order to detect where we can have this emotion. We use different kind of the approaches. We use machine learning approaches. Later, we use ensemble methods in order to try to know that, or try to improve the previous approach. And we use a transformer-based architecture of the cell abstraction layer. The data set that we use have 8 different expressions, the same that the previous one. The name is Radboud face data set. This data set is from Twente University in the Netherlands, Europe. And this data set have 8,000 images, okay? In particular, we have 66 different persons with different kind of race, different kind of gender, different kind of age. And in total, more or less, we can have between 23, 24 pictures for a person with different position of the face, okay? Here we can see one example with this data set. Where we have different kind of expression from different kind of persons. Okay. The experiments, we propose 4 different experiments in order to know where we can have the information, and we apply a 50% holdout cross validation method. In this case, we can use the Euclidean distance. We use the different information from the transform domain. The third experiment is one ensemble for the different previous approaches. And finally, we use a visual transformer in order to have our results. Okay. About the information from the Euclidean distance, we can see that the results is very bad results. It's very difficult to have general information from the different persons. In the second experiment, we try to improve the results. We can see that the idea is to try to use all the segments, the previous segment that we can have, in order to have more information. And we can see that if we use all the segments, okay, or we use the information from the both eyes, is the place in the face where we can have more information about the detection of the expression. Okay. This is the results. We can have about 96% of success. And this 96% is interesting to know because if we apply an ensemble method in order to try to improve the results, we can see that we have the same, or the result was similar results. Okay, maybe no. The reason is because the correlation between the different approaches is very low. We can have always the error that we have always have in the same samples. For the reason it's very difficult to improve the results because have a very so much correlation between the result for the different approaches. And finally, we use a transformer-based architecture, and we use 2 self-attention layers for the age expression. But our result was about near 90%. Is the best result was the previous one in the second experiment. Okay, this is the approach when we want to detect the different kind of expression. Okay, it's the idea. The idea is to we can have information in different parts of the face. Okay, is each part is important in order to have a better accuracy. For the reason we try to use of this way, we can have these results in order to use wavelength discrete wavelength transform. The rest of the proposals is no don't have good results for the reason in order to detect the different kind of expression. This is our proposal. Okay. In order to show to you the another approach is the idea is to try to detect the emotional state. Okay. Now we change the idea. Now the previous one is in order to detect the different kind of expression, in order to detect the neutral expression. That is very important for the neurologists. But now the idea is to detect the grade of the expression, independent of the expression. Okay, is the idea to detect only the grade of this expression. For this way, we propose this this diagram block. Okay, is the image preprocessing is similar to the previous one. The mouse opening is the idea from the neurologist in order to detect the information in this part and to have the quantification of this information. Okay, here we can have the first step is similar, is the face detection. After this, with the face, we detect the low part, the mouth, and we apply a color transformation in order to hide the information of the mouth. Okay. Each person is different. We can have different condition, illumination condition, and for the reason we try to apply the morphological operators in order to improve the mouth detection. And after to have the information, the idea is to sweep all the information where our starting point is the mass center, okay, and we can sweep for this mass center in the shape mount, and we can have the information that we can have in this polar coordination. You can see here this image is when the person have the mouth is open, okay, and here is when it's closed or only move a bit, okay. This is in this case the information that we try to analyze is the information that we have in the green square, okay. In order to do easy this task, we use one approximation because it's very difficult to work with the mouth. We can have different illumination condition, and we can have always a shadow part in the mouth. Okay, this is the morphology of the mouth is it's normal to have different shadow part in this part of the face. Okay. For the reason we use spline curves in order to do easy this task, this detection, and to try to detect or remove the shadow part that we can have in the different images. Okay. After this, after to detect the quantification of the movement of the mouth, we can say that we have a very interesting results in order to detect the grade of the emotion. Okay. After this, we spoke with the medical doctors, and the idea is to try to implement the system. This is our first.
Imagine Teams, la cuenta con tarjeta Bizum para tus hijos que puedes supervisar. Descubre en imagine.com.
This is our first approach. Okay. In this first approach, we can see that we try to detect the part of the mouth. And now we have experiments. The person is not speaking now. Now it's speaking very low. The level of the motion is very low. We can see here, very low expression. And now to try to increase the expression, now it's normal way. And now increase so much is this in this part is angry. It's move a lot the mouth, and we can detect this kind of the expression. Okay. It's very interesting for medical doctor this information in order to know. Now you can see in the video that now decrease the grade of the motion, okay, and we can quantify this information. Now we can have the same experiment. The level of the degree, the level of the motion is very low. Now try to increase the level of the expression. Okay, now it's only speaking normally. And here you can see that we have a very high level. Okay, we can have different kind of colors. And now this this information was very interesting for medical doctor. Okay. Okay. This is one photo of the previous video where finally we can see here all the information. We can have the information in real time, It's very interesting for medical doctor too. After to have, for example, an interview with neurologists, or to have answer from external stimulus when saw a video or something like this, we can obtain this kind of answer where we can see which is the level of the expression of this person. Okay. Is a normal person or the person with Alzheimer, or we can see the evolution of the disease. Okay. About the conclusions, it's very interesting to analyze the both approaches, because in the previous one we tried to analyze the different kinds of expression, and the second one is try to analyze the grade of expression. After to show the both approaches for medical doctor, they decide to work with the grade of the motion. Okay, this is the block. Okay, now we can try to apply fusion block between our previous approach this one, and we want to add more approaches in the future in order to have a more robust decision about what is the level of the Alzheimer's disease. Okay. The idea is in the future to work with handwritings. In this case, we can see here, for example, to use a tablet or a mobile, a smartphone. We can detect different kind of the strands, and we can say different kind of the parameters, that number of strands, variability, time, pressure, derivation, temporal evolution. We can have more information, and we think that we can give more information to this multimodal approach. About the acknowledgement, we have to say thank you for the people from Bern University in Czech Republic, and we can have a research project from the Spanish government. Okay. Finally, I would like to show to you a video with a real patient. Okay, real patient, where we can try to detect this kind of information. Okay, we change a bit this information. We can have here in blue level is very slow level of the disease, and in green one is normal level. Okay. In this case, it's an interview with neurologists. And now we can say that the system is working in real time, and we can have more information. We can have a new modality or new diagnosis test for medical doctor. Okay, thank you so much for your attention. You have any questions?
Thank you, sir, for such a
for the invitation to participate in SPIN 2025. Thank you so much.
Thank you, sir, for such a knowledgeable presentation. Now I would like to invite Dr. Anil Kumar Shukla to present a certificate to Dr. Carlos M.T. Gonzalez as a token of our appreciation.
Thank you.
Sir, could you please unshare your presentation? Could you stop presenting? It won't allow us. Thank you. Thank you.
Thank you so much, sir, once again for your nice talk. So many people have joined on the virtual team through Amazon.net, and they have enjoyed so much your talk. Thank you so much once again.
Thank you so much to you for this invitation and the possibility to share with you my research. Thank you so much.
Thank you everyone for being a part of SPIN 2025, and we will resume with the sessions tomorrow. Thank you, sir. Thanks.
Thank you.
IT department, please close this meeting.